understand that I don't wanna play your game.
The Earth is very flat.
What's going on, everybody? It is Friday, September 24th, 2021. How's it going out there? Got Ian Adams, Vader Paul, Rob Keane, PJ. What's up, man? Gadget Inspector. Yes, the Discord is a hive for troll. Oh my god, yes. You wouldn't believe it. Let's see. Who else? Sean Hawkins. Speaking of trolls. And Page 42. What's up, Page? Brian Stavely. How you doing, Brian? And let's see who else we got in here. Bill G. What's up, Bill? Is that what Sean Hawkins was first? No, that must not go back far enough. Yeah, we'll have to call it a draw today. Anyway, what's going on? Sounds good? Thank you very much. Appreciate it. Sean Hawkins was first in the chat. Gadget Inspector has confirmed it. Congratulations to Sean on your win. I see you've been quite active today as I've gotten some notifications that you put out some videos. Please move your face far, far, far back from the camera. That would be much appreciated. Thank you very much. Anyway, yeah, Friday Night Fights. And what's up, Silent Zero? Says me. What's up, Silent? How's it going? Fuzzy Bush Monk. I like that name. Yeah, there's a bunch of people in Discord already. I haven't been around much in the last couple days. My boss has been working my ass off, so that's been fun, but that's okay. Glad it's Friday, I'll tell you that.
The day just constantly repeats itself over and over again until ultimately he gets his sort of heart ride. But yeah, I'll bring up the opening of Groundhog Day. I think you'll find it very interesting. Here we go.
How did they do that with the clouds? They must have not shown a lot of clouds in the scenes because you couldn't make the cloud, you know, or they just kept reshooting it. I don't know. It's weird.
Well, let me post it here. Okay, hang on. Right.
No, we're about to start the show, Pete. Not right now.
What's going on,
Oh,
everybody?
damn it,
Speaking of starting the show.
DM. What up?
What up? Is there some weird noises coming from?
Yeah, we're about to fix this shit right now. Who's bugging out with their mic?
I was listening in a little while.
Only happens.
Kinds of fucking...
I think it only happens when Pete talks. Mic open. Sounds like this buzz.
Pete, it's you, Pete. You took over from Brian. Brian's got an awesome microphone now.
Oh yeah, you got some crazy background noise going.
Okay, sorry about that. Let me reconnect.
Yeah, reconnect.
Your mic's staticky. It's a mess. Total mess.
Absolutely unacceptable, Pete. Anyway, what's going on, guys? How's it going? We got Biodual, JJ, Chikey, Conrad, Drink of Kool-Aid, Enigma, Earth is Life, Face One, Effie Walker, First Incubus, Geo, I'm your Copernicus, Pete, Jeremy, Moongazing, No Namer, Omni Uber, Rob on the level, Keen, Sean G, Sin Cleanser, Sovereign Container, Steel City, and we power it with, I can't see the rest of the name. What do you power it with, D-Mot?
Souls.
Oh yeah, of course. Yeah, the soul machine. Yeah, I getcha. I didn't know that was public. I thought we only talked about that in meetings and rituals. That's all right. So what's going on?
Listen, you're in the afterlife. Here's a scenario for you, Brandon. You're in the afterlife. Your dad, you just died. Somebody you knew in life, your family member, somebody comes up to you and they're trying to get you to go into this white light. Do you just go into the light or what?
No, I'm double checking and shit. You know, I've been thinking about this for a while, and I don't know what made me so paranoid about this. Somebody was talking about this a while back, but I feel like I need to tell like the elderly people I know, like, hey, when you die, be careful. You know what I mean? Like, wouldn't that be awful if there was some kind of fucking trick?
Yeah, I mean, we're getting you know, people are tricking you in life. Why not? Why would it stop in the afterlife? You know, the
Yeah.
Goldbusters just did a thing on this. I heard.
Oh, did they? Okay, I didn't catch that.
Yeah, I didn't catch it either. I gotta go watch that though, because that's interesting.
Where does the
Yeah.
archetype for the Joker come in?
For the who?
What'd you say?
The Joker, where does the archetype for that come from? You know, Satan, God, you know, Satan being the jokester, or God being the jokester, being himself as Satan. You know what I mean? That idea. The
Democ,
Joker,
back
you know what
off
I mean?
your mic. Democ, back off your mic like an inch or two, maybe.
I'm all way, way away from my mic.
I can't hear them.
The Joker, man. I'm away from my mic, I'm telling you.
Demo,
My
talk louder. I
it's
can't hear you.
just a shitty phone. So the Joker aspect.
Yeah, where do you think it
God.
comes from, Demon?
God, the devil, the Joker, you know, the Arcanons, the shit like that, the syllabuside, like where I don't know. That's what I'm asking. Where do you guys think that does it come from? Like, you know, where does that Joker idea come from? Like, you know, to say the creator is the Joker, you know, that does this and this, good and bad, because he creates these control.
You say the Joker, but what about the mask? That's before. Well, I don't know. Actually,
No, I mean,
they had the Joker way before, didn't they? So yeah.
Yeah, I'm talking about God. Yeah,
that's a god.
Well, if we had created, so let's say we create like AI or something someday, right? We would absolutely be trying to trick this thing because, you know, we would want to keep it contained. So we would try to trick it to thinking it was in the real world. You know what I'm saying? I mean, we even trick our own kids with Santa Claus and Easter, and it's not forever, but
the movie of Ex Machina. This is like the entire plot of that.
Dude, I love that movie. That's a great movie.
Yeah, I gotta check that out.
Are they gonna make a second one? A second, like a follow-on Ex Machina? Because at the end, well, I shouldn't say it, I guess.
Yeah, I didn't see it. What's the name of it?
Yeah, no spoilers, Brandon.
Ex Machina.
Ex Machina, yeah. It's pretty cool. There's a hot robot in it too.
Yeah.
Yeah, if you like hot robots.
Machina.
Oh, hell yeah. Hell yeah.
If we don't have any particular topic
we're
going on right now, I do have a question.
Can't you hear the important conversation we're having, Bob?
We're about to start talking about
sex
robots.
Taking place. We talk about that.
We're one step from sex robots.
The descriptor that you provided about that conversation is not necessarily, you know, a descriptor I would agree with for that conversation, but I did hear that you guys were having a conversation.
Okay, all right, fair enough. Well, I guess go ahead then.
Okay, so what I was thinking about was what the claim is for light. They say that it's a particle and a wave or whatever, but what do they claim happens when light goes through something like stained glass and it's still colorful when it hits the wall? Wouldn't the claim have to be that the particle is somehow picking up something from the glass and taking it with it when it hits the wall?
That's filtering.
Oh, that's an interesting thought. Huh.
It's actually
because
filtering.
if it's retaining the color, and it's a physical thing in our reality that's moving, it must be taking something with it when it goes through the window to retain the color and hit the wall.
No.
So Moyak, you're saying blue glass. Moyak, you're saying blue glass filters out.
Image of itself.
Hold on, Democ. You're saying blue glass filters out all the other spectrums and just lets the blue light through?
Essentially, yes.
Huh.
Okay, so you're saying you're saying the claim is that the light, like from the sun, is literally every possible color in the world all at once, and sometimes it'll filter out all of the other ones except for certain ones or whatever to then make a certain color for us.
Yes.
Not
That's
for
why
us.
you could use a
Based
prism
on
to
material
separate it.
goes through.
So in blue glass, all the wavelengths or whatever the other colors are, they all get blocked and only let the blue. Why? Why does it only let the blue go through? Because the glass is that color?
It's a
Smart
particular
glass.
wavelength. Particular materials will or particular colors will
It's
absorb
smart glass.
certain wavelengths, but they'll reflect other wavelengths. So if you have this, if you have light from the sun, for example, and it essentially, for lack of a better term, carrying all possible colors, if you have a material, it'll absorb a number of the colors and it'll reflect a number of colors. So you get that reflection, not the absorption.
Yeah, but we aren't changing the material. We're just changing the color of the material.
So how does a clear so how does a clear object get all the colors?
Same one.
Not reflecting.
So why does a clear glass get all the colors?
No, it's not absorbing. It's both not reflecting and it's not absorbing those wavelengths. So the light just goes through. But as far as the colors, it's or using a mirror, the mirror isn't absorbing it as well. It's just
How does
reflecting.
it decide which color?
It doesn't
What's
decide.
The property that allows certain things apart from others.
I can't tell you.
I'm not sure. Yeah, no, that might be a good question. That might be
Welcome to
the
Flat
best
Earth.
question
There
of
you go.
the topic. Yeah, there you go.
No, I don't know. Doesn't mean flat Earth.
Yeah, that's kind of a
No,
jump.
I mean,
but
we
no,
live on
that
a
was
flat
that
Earth,
was a good
so
question.
that's already settled. Yeah.
Yeah, that was a good question.
Yeah, I was just
Sinclair.
adding welcome. Yeah, because then you're gonna find out you don't know a lot about light, and then you're gonna get into ether, and then here we go.
But like, okay, but guys, think about what you're saying. Okay, light is particle and a wave. Okay, and the particles they're hitting the window that's colored glass. Okay,
Yep.
and what you're saying is that the color somehow changes which particles physically get through the window.
No,
That's
that's not what's being said. We're talking about the wavelengths, not the particles or lack thereof particles. The wavelengths.
They will be absorbed. In fact, if you were to actually measure it out on the spectrum level, you'll find that it actually doesn't even block all the other colors. The filters inherently usually only filter out a portion. So like if I was to hit it with a red light, all it would do is attenuate that red light severely to the point where the blue would overtake it. You know, so
It'd be purple.
shining a red light through your glass, I would guess, would tend to show a more red light.
Is it blocking any of the particles?
Is it blocking them? I don't know if it's blocking, it's absorbing them. They turn to heat.
So
Smart
yeah,
glass.
it is blocking them in a sense. Yeah.
But some of them, I would say, would get through. I'd have to actually validate this because I'm doing this theoretically at this point. But I think if I shined a red laser, really strong red laser, it probably would show red on the ground, but it would be attenuated severely,
Okay,
So all you gotta do to block out harmful rays is paint your stuff blue or green or purple or orange.
That's 100%. That's 100% exactly what we're saying. If you don't want to get skin cancer, paint yourself different colors.
So when the light hits the glass, it slows down, right? As it passes.
Wait, hold
as it
on,
travels
guys.
through
Hold
the-
on.
Oh,
my bad. Go ahead, Bob. Go ahead, Bob.
The color thing. Okay, so are the particles that get through the window, and therefore we're seeing like a certain color of the light. Okay, are does each particle have the potential to be literally any color, and the wavelength determines which color the particle is going to be?
No, essentially you've got an infinite number of particles, near infinite. You know what I mean by it. There's a shitload of particles coming through. Some of them are red wavelengths, some of them are blue wavelengths, some of them are green, all the way through the spectrum from radio frequencies all the way up to light to gamma rays. So it's going to be all those frequencies. Now, from that, I'm going to filter out. I'm going to turn some of those into heat in my filter, my glass. Some of them will pass through relatively unimpeded.
But that brings us back to the question of how does changing the color and not the material determine which physical things will actually get through the window and which ones won't? That doesn't seem to make good sense.
Right.
The only way I could, like I said, I am not a light expert, but what I would say
Hold
is...
on, Denmark.
What I would say is that you know how a microwave, the screen in a microwave keeps you from getting microwave in your eyeballs? The holes are too small. If you made those holes a half an inch, those fucking things would come right out and burn your eyeball out. But when they're a millimeter like they are, the wavelengths can't get through. Something similar to that in the lattice of the glass. I don't know exactly how it works. It's similar to that.
Isn't it?
But we're
Isn't the
talking-
glass a certain color already because, that's what light is getting through. That's what light is bouncing off of it. That wavelength.
Well, there's that.
So if
too,
you're talking
yeah.
about
I mean,
red
that would also be
glass,
part of the claim.
yeah, right. So it's
Yeah,
red
yeah. If you're
because
talking about like a red glass, then light's gonna hit it. It'll absorb all other colors, but it'll allow red, that wavelength, to pass. So when those photons that have that wavelength go through it into our eyeballs, we interpret it as red.
yeah,
But,
so
like-
it doesn't matter if you're shining
but
a
what
laser
he's
through
bringing
it or
up
if
is
you're
that
just looking at
it's
it.
only red because it didn't let them pass, because that's how it got to our eyes, so we knew the glass was red.
Right. That I would say is there's some refraction, whatever. There are some of the light particles are coming back toward you. That's why you can see the glass in the first place.
Right, but
So-
we know it's not. We know it's not the opposite, because we can set light to a particular wavelength, such as lasers. So we can dictate the color based on the wavelength. If it were the opposite, we would have to transmit all other wavelengths except for that particular one. Then we would get red. But we know that's not the case.
So what's magenta then? If someone can tell me the frequency for magenta, if that's okay,
There
I'll
is no
just get a pen.
frequency for that. It's two colors, or at least two colors.
It's not a real color, is what he's getting.
Now we complicate things.
Yes.
Magenta's not a magenta is not a real color, Mark. That's what I asked you.
Are you colorist?
The color your mind makes it up because it's not. If you look at the spectrum, it's actually outside of the spectrum. It takes the two ends of the spectrum and combines them together, so it actually doesn't exist.
Is it?
It's not a real color.
I thought it was a mixture of red and blue.
It looks like it, but
it is. It's more of a
Your brain
it's more of an
can't see it.
RGB thing that you're going down. It's not the opposite ends of the spectrum. It's not the purple.
Yeah, it's a mixture of colors.
it is the opposite ends.
Yellow
It's a
yellow is the only
combination of
one-
the opposite ends of the. It's a combination of the opposite ends of the spectrum.
As I
No,
understand
mine
it,
feels
yellow
in.
is yellow is the only not
It's
real
human
color.
exclusive, let's say.
Is the question?
Why isn't the ISS made out of green glass?
Is the question then? Is coloured glass diluting the light?
Sure.
Filtering?
I wouldn't have a problem with that statement.
Because transparent's much better. If I understood the question.
Yeah, but if you colour the glass, would it be less transparent?
So we can see it, but it doesn't exist.
Yeah, essentially, Omni. Yeah, if you have perfectly transparent, that all photons are getting through. I mean, if it's colored red, it's less transparent because it is absorbing, and you're only allowed to see red, I guess.
Kosho.
So that's right.
So we can see it, but it doesn't exist.
Yeah, your mind makes it up.
Your
Does
mind,
our mind
makes
make
it up.
everything up?
Doesn't your mind pretty much
No, only
makes
just
everything
one
up?
color.
Just that one
Just that
color,
one
huh?
color.
Yeah, just that. Just that. Only that.
But then when we're talking about millions of light years, then that shit.
No,
is
that's
there.
definite. No, Silent Zero.
Oh,
That
your
is
mind
100% reality.
So
Yeah, that's subtle science there.
is an assumption.
Set of science.
But they're exactly right about all the
Very
absorption,
much.
emission, and transmission. That is the whole essence or groundwork for nuclear physics, basically, and all the spectra lines.
I
What
do have to
goes
say
through,
one
what
thing.
reflects,
I just tested my theory.
what absorbs.
With I took a red laser, I fired it at a blue lid, and red still came through, but it was almost invisible. It was so well attenuated. So even though I was shining a light at that blue thing, no blue was showing up on the paper, only red.
That's interesting. And listen to this. Magenta is a subtractive color. It is minus green. So it's a combination of red and blue light. Minus green. That's weird, huh?
Do you know what green is? Well, green is the last color humans see before passing out. Also
I am
related
aware
to
of
the
that.
green- There we go.
The last color you
Wait
see
a
before
second.
passing out.
Wait a
Why is
second.
that?
It's because it's the last visible thing or the last thing that a human will see before they're dying as well, because it's the next noticeable color, let's say, is black, as in complete darkness.
Green is a mixture of colors. So how do you have minus green?
Maybe it's your brain performing spectroscopy.
I guess we do that, but like really poorly. But
Here's what it
I
says.
actually
If
was
the
surprised.
blue,
Good.
if the blue area is filtered out, the resulting mix looks yellow. If the green mix is filtered out, the result is magenta. So it's like, for some reason, I don't get it. Minus green. I guess it's blue and red, and you minus the green. Makes sense, huh?
But green is not a real color. You know, it's not a primary color. That's red, blue, and yellow. Well, yellow's not real. I hate colors. Fuck you.
Green is real color, though.
It's not a
Colors are
primary
stupid.
color. It's a secondary
All colors
color.
are equal.
It's just that magenta doesn't actually have a wavelength. Like green has a there's a wavelength for green light, but you wouldn't be able to produce magenta light. There's no wavelength that corresponds to.
Now, what if I tell you that I've invented a magenta frequency generator? What would you say?
Cool.
I'd probably
Be a
assume that
billionaire.
you're transmitting two wavelengths
I'd say-
in one beam.
No,
That's my assumption.
I'd say you have a square magenta color, a color of square magenta color, like you have a magenta color somewhere on an object, and that's it.
There's a huge untapped market for magenta wavelength. So.
Generators.
Yep.
We can get to space on it. It does actually contract length as well. Contract color.
Sure.
It's color contraction and time something.
What if we haven't figured out a apparatus that detects that wavelength?
Wavelengths aren't something that like are really hard to determine. It's not like something you could not detect. They're sequential. You can tell.
If you haven't seen it,
We've seen every wavelength from 0 hertz to gamma rays.
and that's all that is in existence. There cannot be something else that we
There could be
cannot
something
figure out.
higher. Yeah, basically the frequency can keep going up, and there'll be a higher energy gamma ray and stuff like that. But we sort of lumped all gamma rays into one category that I know of at the moment. And then below 0, I don't see how you can have a frequency below 0.
Well, that's the
But
thing,
mind
right?
you, if we bridge this to sound, there's sounds that we can't hear that have a value. They have a.
I'm speaking my language.
Yeah, sure. We have a
You know why
range.
humans can only hear from 20 to 20,000 hertz?
Something like that. Probably a couple
But
of
there's
outliers
sounds
who exceed that.
that we don't hear.
I said, do you know why?
Oh, no. I just did another
Frequency
test.
again.
I shined my red light through my laser through a piece of red glass, and it went through relatively unimpeded. Some of it stayed on the surface, but you know, it still was very bright on the surface I was shining on.
I think if I can give you an analogy to figure out the wavelength and how it blocks and reflects and stuff. If you can imagine a house fully locked in and it's had a flood inside and there's water up to the letterbox of your front door. Now there's a wave coming because your bathroom's overflowed or something. There's a wave coming which is double the size of your letterbox. Now it's exactly halfway, the water's coming out halfway in the letterbox, but because this massive wave is double the size, you will get half of the wave cut off, or the motion, the forward motion of it, get cut off and reflected back because of the splashback. Obviously it can't go above the letterbox, it can't go below the letterbox, so it will then come back on itself. but then you'll get a certain amount, then fill the letterbox and go through. Now, that's exactly similar. That's a good analogy as to light and filters, where you will get a certain wavelength or a certain space between the filters, and then that will take away that proportion of it won't allow a certain proportion through, let's say. And then you've got polarization, which is a different thing as well.
So have we made any ground on this with the filtered or with the light confused people?
Bob, are you satisfied now?
I wouldn't say I'm satisfied, but I'm not necessarily going to push the issue right now.
Well, I can't explain
If it
that as a
helps
particle,
any-
by the way.
What was that?
If it
can't
helps any, you can calculate.
sorry.
There's a calculation for wavelength. I can DM you that so you can calculate the wavelengths. Okay.
Okay. All right.
Frequency over time.
Yeah, you know that any kind of glass or filter or anything like that, it's working the same way a reflection works. It's just that allows the light to pass through it. But the same way, like if you shine a white light onto something, and you're seeing blue or red or whatever, it's just because it's reflected. I mean, it's absorbed all the other colors, all the other parts of the wavelength, except for what it's reflecting back at you. And that's the same way. The a transparent filter works, except for it
But
just
if
allows
it's
the light to pass through
absorbing
it, so
all
it
the
bounces
other
back.
colors, if the glass is absorbing all the other colors, shouldn't the glass then be all the other colors, not just the color that it's letting through?
Sure. Then you can go ahead and say that. You can say that it is those colors, but that's not
But
what
it's
you're going to see.
not.
You're going to see
Obviously, it's not.
Yeah. Well, no, it's not. Yeah, exactly. That's my point. That's why it's not said. But whenever you shine a light onto something and it's coming back blue or grass is green, the grass is actually absorbing all the colors except for green, and it's reflecting that back. So you could say, oh, that grass is actually everything but green. But of course, when you look at it, you're going to see green because that's the light that is coming back at you.
But the stained glass is, according to your claim, the stained glass is only letting through that particular color and absorbing all the other ones. But the stained glass isn't looking any other color.
Well,
Yeah, Bob,
I can
it's
answer
this
that
simple.
with my little test.
It's very simple. The simple explanation is that glass is absorbing those photons at those wavelengths. So there's no reason that your eyeball should see a different color because those colors aren't touching your eyeball. They're being absorbed rather than reflected.
Okay, but then how are they getting through to where the light is hitting on the wall inside the building and being that color then? If all the other ones are being absorbed and the other ones are being bounced back to your eyes so you know that the glass is red, how is there anything getting through for the light to be red then?
You would have to get into some chemicals. Like right now, I'm using like opaque plastics and stuff like that, which actually are not perfect passing through. I know that they have some liquids that will filter, but they'll still appear clear. So you wouldn't see the light reflect back at you from a completely clear liquid that makes the light, that filters out all the light but the color in question. So
well, here's the deal also.
You have a material that's not perfect, so it does reflect also the red light.
When objects absorb light and reflect everything else, and whatever it is the case, when they absorb light, they're absorbing the light, but that doesn't. You're not going to experience that absorbed light. Only that object. I mean, the object just happens to absorb those wavelengths of light, but that doesn't mean that you're ever going to see that object as being that color or anything like that. It's not how you experience it.
I think what it gets converted. Yeah, heat. I was about to say. I think all of those colors are being turned into heat. So black absorbs all color. It doesn't reflect. So that's why black is so much easier to heat up because it's absorbing everything rather than just some of it. And I guess similarly with white. That's why you wear white on a hot day because it reflects everything. So obviously not everything, but it's going to reflect most of it, so it doesn't heat up as well as wearing black.
That's why Banta Black is so black.
Yeah.
And they have new white that's so white that it reflects oh god, it's insane.
Thing in the vacuum.
99% of all light.
What about the thing in the vacuum tube where it's got the black side and the white side, and it's like a pinwheel kind of thing, and it spins?
It rings a bell, but
Wait, say it
You're
again.
talking about those
When you
light
shine the light on it.
generators?
Crooks
Yeah,
radiometer.
those generators?
It's in a vacuum. One side's black, one side's white. When the light hits the black side, I believe it makes it.
Radiometer.
Oh, the
I've
thing
had
that
that
can be
experience
pushed
once or
with light.
twice, and it
Is that what you're talking about?
baffles.
Yeah, the light pushes this thing. Yeah, that's what I'm saying.
Yeah.
Certain
It's not in a
frequencies
vacuum though.
yeah.
It's actually a partial vacuum with still
It's
gas
always
in
a
it. I believe
partial.
the,
It's always a partial vacuum.
No, it's very partial.
What do you mean so? Yeah, I mean so.
The deeper the vacuum
You
pull,
know.
the less it will work.
I mean,
Yeah,
how's
my
this thing?
physics
If this
teacher.
thing has no. What's up?
Go ahead, man.
It has to have little enough gas in it that it doesn't impede its motion, but enough that it can actually impart the motion. Because I believe it's, if I'm not mistaken, it's the heating of the surface actually has the molecules in there actually perform the motion. I'm not positive though. It's like there's like multiple things going on there. It's really hard for me to understand.
Yeah, I was going to say
thought it was
this.
just,
This is the work. Sorry, it's the work of Einstein. This is his Nobel Prize. I mean, not Crookes, obviously, nothing to do with this, but that was his thing of firing photons and finding that when it hit a metal sheet, you get another photon hit back or an electron bounce off, should I say? And that's what they're saying is the cause of this. It's either heating up the little bit of atmosphere that is in there, or it's the electron coming off of the bulb and hitting the actual sails. That's what they're called.
Make sure about that because I believe that's like one of the minor effects. To get the effect, you actually the reason you have to have a gas in there is because there's also momentum cast on it by the molecules in there. So I'm not positive. I said the explanation was
Yeah,
like,
no, that's what I said first. Sorry, that's what I said first. It heats up
Okay.
the atmosphere around it, and I said atmosphere instead of gas. But yeah, no,
Okay.
that is exactly the original cause. That if you read that wiki article, it will say, yeah, it's
Yeah,
a
just scroll down to,
transference and right-hand rule.
yeah, if you scroll down to correct theory, I'm trying to find Reynolds' actual experiment, but essentially, yeah, that explanation. It heating up one side, and then the little material that's on the inside tends to move from hot to cold, and then that pressure differential is causing the movement. Yeah.
Same way how tornadoes are formed from pressure differentials and the right-hand rule.
Pretty
Are you saying that
interesting,
this
yeah.
Crookes radiometer spins because there's a pressure differential?
So that is one explanation for it, yes. The other one is photons are hitting it, but then you've got the explanation of, well, photons are massless.
and we
They're
can also
hitting it with
validate that that's
just
not the
energy.
case because in the absence of an atmosphere, it doesn't move. Or in the
Right.
absence
But
of
mass,
Light,
They-
the
they
light
have
could be altering the temperature.
they
which
have
would be
momentum,
increasing
though.
the pressure.
they do, but
They have momentum, but they're
puny.
massless.
yeah,
Doesn't that seem like a
energy.
catch-22? Tell me how that's not a catch-22.
yeah, it does.
Their energy.
Yeah, it does seem like it, but it's defined defined differently. It's not the same kind of momentum. Yeah, it's not the same kind of momentum. I forget what the name is, but it's not the same kind. But it does have momentum.
Yeah, I've heard
Right,
that.
but
before.
like I said, you can validate that that's not the cause because in a complete vacuum or much better vacuum, it doesn't work at all. There's just not enough momentum from that laser beam. Maybe if you kicked it up to a gigawatt, you might get some motion. But
Equivalence principle. Or mass energy equivalence.
because they
Now we're
do talk
getting
about
into La
using
La
it
Land.
for powering spacecraft, lasers from the
Einstein's
ground
greatest thing.
on big solar sails.
Okay.
I think the technical explanation is this: the thermal transpiration. Trying to find more info, but that's what they're attributing the explanation as, the technical term.
What's that mean?
It's basically what we were just explaining, kind of. as you heat one side, you're creating a pressure differential in a way that the gas from the hotter side wants to move to the colder side, and because we have that movement, it would cause those blades to move.
I thought it was in a vacuum.
As we know, it's not all perfect. So there's a balance between an extreme vacuum where we don't. If we had an extreme vacuum, we wouldn't have enough molecules on the inside to do anything of use. And if we have too little of a vacuum, there's too much air resistance for that mechanism to move. So you have to have that balance of enough material as to cause movement, but not too much material as to hinder movement.
Okay. Hey, I got a question that's kind of related to all this. I was just thinking about this last night. If I had a spaceship that was capable of going light speed, and I flew it, say, I don't know, from Earth's upper atmosphere just out into space, just under the speed of light, would I have to design it in a way to be careful of impacting the gas molecules in the in space? I know there's just a few, but I'm going so fast.
Yeah, I think they'd be like nuclear weapons.
The gas molecules would?
Yeah, I think that they would strip the skin off of your spacecraft relatively short order.
Right.
That's why warp speed only works when you have shields.
Good point. Well, the reason I was thinking about this was we were talking the other day with what's his name, the guy who looks at the twinkling lights in the sky for a living. Anyway,
Seems Chronic.
Chronic. We were talking to Chronic, and we were saying, well, why couldn't it be caused by what's it called, refraction? And he's, well, no, refraction is not going to happen through space. There's so few molecules. I was thinking, well, it's going so fast. I wonder if a spaceship went through space, if it would have to worry about the gas molecules, and if it would, why wouldn't light be impacted? If a spaceship would be impacted, why wouldn't a photon or whatever?
What is the probability of
Because
a
it has
spacecraft,
no
let's say
mass.
with a 36-inch diameter, running into a gas particle versus what is the probability of a light particle hitting an atom of something? The probability
Well, if it's
goes
coming
down a
from
lot.
707.5 billion light years away, I would say we could probably calculate it, and it'd be pretty good probability it's going to hit a few along the way.
Right.
It's
now,
not going to
we
make
know
a
that
physical impact. It's not going to make a physical impact. What it might do is heavily charge the ship with light intensely from one side, right? What's that going to do? Maybe charge it. Light doesn't make physical impact. It only charges.
But as it
I
hits,
wasn't
like,
talking about the
you
light
know,
hitting the spaceship, or when I was talking about the light hitting the gas molecules.
Yeah,
and I don't know
thing is,
enough about refraction to say what happens on a single molecule basis. I only think
doesn't
about it
do
in terms
anything.
of large. Are you sure?
Yes.
Will it be re-emitted?
There's not a of course, there's going to be some particles that hit some gas molecules at some point, but because that is random and few and far between, those aren't going to amount to anything that you. It's not going to change your picture. You know what I mean?
Yeah, you guys said this the other night that one particle wouldn't impact or affect a light, and I agree it might be a very small impact, and I don't know why we're talking about just one, but every time light hits a air molecule in your model on Earth is when the change happens. Light can't hit more than one air molecule at a time, right?
I would say, like, there's one thing that, like, I don't know how I don't know how refraction works exactly, so I'm talking out my ass here a little bit. But when you're going down and, like, taking 1 liter of air at sea level versus the amount of air between us and Alpha Centauri, I would say that it would be similar numbers of molecules that you'd be interacting with. From just going through that 1 liter bottle versus all of the space between us and Alpha Centauri. So how much would you expect that light to change? Since in a liter of air, it doesn't change very much at all.
Well, let's think about this, because it's going to hit one. If that deflects it in a certain direction, it's going such a long distance between them. It's all about how much it deflects it, right? So you've got distance and the impact from the light hitting the molecule. I don't know.
Yep. And it also would be inherently, I would think, random, because it's going to hit one atom at one angle, the next atom at another angle. You would simply just get a slight scattering of light.
Wouldn't it tend towards whatever, I don't know, massive objects there are up there, since the masses are attracting the gas molecules in the heliocentric model? So
I don't know, what
it
is
would
the
skew
actual
towards
attraction
those.
what is the actual attraction between a molecule that's 6 billion miles from the center of a star? It might be moving that way, but we still got another trillion years before it starts to make any appreciable progress to it.
Yeah. All right.
What?
Anyway, we're pretty deep in La La Land, but I was just thinking about
Here's
that
a
for
quick
some reason.
question. Here's a quick question. When does
Was that an
oh, this
Arwen
is-
what though? That was classic.
This is still La La Land. Hold on a second, please. This is still La La Land. This is still La La Land. But when does the gas stop rotating with the Earth? You know how it's all rotating with the surface of Earth. When does that stop happening in the heliocentric model? I'm just
I don't know
curious.
if it ever does. I would say it's probably a gradient again.
It's a gradient.
Yeah, it's going to be that it goes slower and slower and slower until you can't perceive motion anymore. So I mean, I guess
That's the
all
exact
that
opposite.
plays.
Exact opposite of what they say is happening. They actually say it's getting faster as you get higher in your model. I thought you would.
Gas molecules are getting faster, but he's saying he's talking about when he says faster or slower, he just means matching the speed of
Don't
with the
try to
surface
save him,
doing.
Coco. Don't try to save him.
I mean, I just
Well,
understand
actually,
what
I'd
he's
like to know
saying.
more about this going faster. Like, what is the velocity of air? In what direction is that air going? Because you're talking about there's velocities associated with the amount of energy being imparted into it. That's sort of randomized from the sun.
You would think. Well, what you
So
said
are
was
we talking about that,
what
or are
you
we
said.
talking about
What you
the air
said would be.
direction?
What you said would actually be, that's the intuitive thing to think, oh, it starts slowing down. You'd have, it starts slowing down as you got higher, but it's actually, they have it going faster for some reason.
Right, but is it going in a direction faster, a specific direction, or is that just individual particles are now randomly being hit by light and energized and going off in all directions at 20?
It's rotating. They say it's rotating faster.
Okay. I don't know.
That's
I
what
don't have a
guys
theory
say.
on that.
Are we talking
Well, it
about
has to be because it's all in lockstep,
spinning
right?
air
I guess Jeremy's
throughout
asking,
space?
when does it stop being in lockstep? At what altitude? Away
Yeah.
from the Earth.
Yeah.
But
Exactly.
it's not in lockstep. Like all through the atmosphere going up, it is going slower and slower, and then there's a point where I guess it goes faster.
What's up, Brian?
Go look at
So you're saying that as I go away from the Earth, the speed of the air in relation to the speed of the Earth, or the speed of the circumference of the circle around the Earth where I am, is going to be slower. So it's going to like lose its momentum as I get further away.
It's not really losing momentum. It's still going the same speed, but the radius is bigger.
How is that?
The
atmosphere in lockstep. The
how does
atmosphere
it
in lockstep
maintain
is
momentum
more
if
La
it's
La
gas?
Land than refraction in space.
Yeah, no, I get you there.
Or shit.
Yeah, it's not absolute lockstep. It's close.
Absolute horseshit.
As I understand it, it does drift along
I
as
work
higher
with
temperature.
fluids. I work with
How does
fluids
the gas
every
maintain
day,
momentum?
and it won't happen. Can't
So you're
happen.
saying,
Won't
you're
happen.
saying that where you're spinning your propeller in the fluid, your impeller, near the spinning impeller, it's going to be going at almost the same speed as the impeller, right? And as you get further away, it's going to start drifting behind, but it's still going to be going the same general direction.
What I'm telling you, if I've got what I'm telling you, if I've got a tank of water, which is 1 meter in diameter, right?
Sure.
And I've got an impeller in there that's traveling at 1,500 RPM, just in a 1 meter tank. The biggest rim velocity that I reckon, just calculating it, is probably 20 or 30 RPM. That's all it's going to get to. And yet the impeller's going at 1,500. Like if you think that fucking gas, listen to me, if you think gas is just going to stick to a solid ball, you are a moron, my friend.
Well,
At 1
it's a
millimeter
false equivalence.
What speed is the liquid going?
No, this is false equivalence. You have two surfaces there. We only have one.
That's true too, but what
Well,
speed is it
no.
going? Right at the
Actually,
implied
according to
surface,
what you're
millimeter
saying,
away?
say it again, Moyak. I stepped
At
on you.
1
Go ahead.
millimeter away from the impeller, what speed is the liquid moving?
Well, I wouldn't have a clue, but what I can tell you is it would be being thrust away from the propeller. It wouldn't be spinning around with the propeller. It would be being pushed away from the propeller.
That's true. We also have a force involved, but
Yeah, there's an attraction involved in what's going on here, and there's not an attraction being involved there. So of course it's gonna be flung away. But I know you said gas is not going to stick to a solid object, but we do know that everything, whatever the reason you want to say the reason is, everything is compelled towards the Earth. So
That's hang on. Sorry. I apologise, Kosho. That's I've misspoken in how I've said that. Yeah, I understand you think that the atmosphere sticks to the Earth through gravity. That's not what I'm talking about. What I'm talking about, if you think that massive or that area of gas is going to spin around, like stick and spin around with the Earth, that's the bit I'm saying you're a moron. I'm not even arguing. I'm not arguing gravity.
How does it do that? How does the gas retain momentum? How does that work?
What do you mean retain?
Who cares? It's kind of critical, you know. We're talking about physical reality, right? Fluid? No. Gas is a gas, not a fluid.
Gases are fluid. Gases are fluids. Absolutely.
Yeah,
Gases
but
are
that doesn't concern the
Take a
specific rate of gas.
Just spinning in the tank with no liquid. The gas in the tank doesn't start spinning at 1,500 RPM.
let me ask you this:
Well-
if I take your fish tank example and I put it on top of a really good bearing, a good ball bearing system, and I take your little spinning impeller in the middle of it, what'll happen to that chamber after a while? The whole chamber will start spinning. Won't it? So all the molecules will start catching up and doing the same speed, or at least very close to the same speed. Eventually, that whole container will be spinning near 1,600 RPMs, barring some friction changes.
Except for the gases, though. They don't. They will
No,
keep
everything.
being dragged behind. They never eventually start step spinning.
If I did
Never.
the same thing inside of a bowl with a impeller, that bowl will start to spin along with it. If I have low enough friction, it'll
Propeller in
carry
there.
on.
Yeah. As long
Just
as
with
an
gas.
object, a physical solid object, keeps pushing the gas, then it will move around accordingly, according
I
to the
do this
local gas
every
pressure
fucking
differential.
day, and yet everyone just wants to talk over me like they know more than I do about it. I love it.
Go ahead, Effie.
the thing,
Well, again, like my microphone's not that good. Owen, if you want to talk theory, that's terrific. I do this every
Theory?
day, buddy.
Excuse
No,
me,
I do
theory?
this- Oh, forget it.
Are you contradicting my statements? Mentioning theory? Is this some
No,
niche theory
you're speaking about different things.
Owen, I'm irritated that you just jump in and talk over the top of me when I have practical experience in this area, and you're just talking head knowledge.
So
That's
do
what
I.
irritates me, buddy.
Oh, well, I'm sorry. I went through physics class too, you know. I've seen a lot of actual experiments being performed right in front of me, tests to figure out how physical reality works, right? And I got a good grip on it. So I got practical experience too. You don't have to be so patronizing.
Well, in physics class, they did teach you that gases are fluids. So keep that in mind. But it is
But
important
that's
to
not
note that
relevant though. That's kind of a straw man insert because
well, it's not a straw man.
fluid.
You did just say
Yeah,
that.
it
But
is. It is. No,
regardless,
because gas doesn't retain momentum, and
that's fine.
liquid does.
I'm just
So to
saying when
then
you state it, you
classify it
stated
in
that.
an in-between state kind of sidesteps the issue.
It's demonstrably false, though, because, like I said, you could do the same thing with the fish tank and air inside of the fish tank, and the impeller will impart momentum on that fish tank that's sitting on the ball bearing. It will start to spin along with the impeller.
Yeah,
Now,
but this
the
whole thing.
only thing the gas is going to do is going to get pushed around by the container walls.
No,
right?
the gas,
That's what makes it move
air
with it.
gas will move the container.
No,
This
gas
whole
only
thing is
gets moved around by air
it's
pressure
not really
differential.
such the same. The reason it's not going to look similar to what's happening on Earth is because you have to ignore the attractive force, and in all the examples we're given, there's no attractive force.
Right.
So there's something that's attracting the gas.
The reason why it's not going to look similar is because gas has
reason
no
I said.
intermolecular bond. It's because gas has no molecular bonds, and it doesn't move in sync with solids.
Well,
that's not what gas does.
That's a completely irrelevant point. It's a completely irrelevant
No,
point
that is
because,
the.
as I
What do you
said,
mean irrelevant point? That's the point.
because
of
it has
all of
nothing.
them.
It has nothing to do with what the reason I just said was because the attractive force that is that describes why things go downwards on Earth. That's gonna be a huge compelling factor in why the gas is was moving with the Earth's rotation. It's being compelled down. If there was no attractive force, it would only have
there's a reason why
a repelling force, and it wouldn't be anywhere near the Earth.
Right, you can say there's some other reason for why it doesn't happen, but in reality, gas doesn't do that. That's why it doesn't happen.
Well, I just demonstrated it does, Jeremy.
No, you
At least
you
Really?
demonstrated
Demonstrate gas
assuming
go
I'm
down,
right.
go boom boom. Come on.
Kosho, that's
Assuming I'm
funny.
right, and I think you know I am.
Kosho just got done telling us that we can't demonstrate it, and now here you are telling us you did demonstrate it.
I did not just say we can't demonstrate it. What I said was
They admitted
everything
in
that we're
Gems
talking
last
about-
night that they couldn't.
I said everything that everyone's talking about is not the same as what gas are doing on Earth, for the reason that there's no attractive force in any of those examples.
Well,
Right,
where's this demonstration, Moyak? I missed the demonstration.
I can impart momentum on that fish tank with my impeller without touching the walls with just air in the container. If I spin that impeller, that fish tank will eventually have a torque, a twist imparted on it by that non-intermolecularly bonded material.
How is this equivalent to the Earth surrounded by an atmosphere? I don't understand.
Yeah, man. The equivalence is that would
The
actually
Earth
be even
doesn't
more
have a
likely to do it
propeller
because there's
attached
no
to it to
force
push the
against
gas with it.
This is ether. He's an ether believer.
Begging the question that there is a vacuum around us.
Yes.
The Earth doesn't have
There's a
propeller
lot of us
wings
verse him.
attached
There's a
to it
lot of
to
us verse him.
propel the gas
There's a
with
lot of
its
us verse him.
rotation.
Why don't we let Moyak finish, guys? Come on.
Well, I mean, we do know, and so it's a pretty safe bet. But you're right. I don't know for absolute sure. But the higher I go, the pressure goes down, and that hasn't varied through any test. So right now, we can say that it gets pretty close to a fucking vacuum.
All right, let's not get sidetracked here.
That still doesn't imbue gas the ability to retain momentum. Can
Well,
only
again,
be
I just
spun
showed you that it
around
does.
if there is a surface, a solid surface, actually exerting air pressure differential in order to force the gas to move to equalize the air pressure, and that's how it moves by being pushed physically by container walls or propellers. Without a physical object pushing it forward, it's not going to move. Unless there's maybe heat issues, heat can create local air pressure, all that.
Well, we know the surface
other
of
than that,
the Earth is not smooth, right? We've got trees, we've got mountains. So over a long period of time, rotation of the Earth is pushing been pushing
No, that's
the
exactly not how it
Oh.
works because gas doesn't retain momentum.
How have you
right?
determined that's
Listen,
not how
listen,
it
It
works?
might
people.
push
Take
it.
a, take
It
a
might
number.
push it
Take a number.
locally at the ground level, but up there, no, it doesn't because air doesn't
Okay.
retain momentum. It's
So
not
it
going
might-
to.
Hold on,
so
this
it might
is my
spring.
wheelhouse here. Let me ask you something,
Okay,
Earth is
so-
life.
Wait.
Earth is life. Can you show me the physical mechanism by which this happens? Can you give me a demonstration? Point to me on Earth. Show me how I can witness the Earth pushing the atmosphere along with it, as you just
Well, you
described.
could what you could do is, I mean, you could get like some sort of fish tank or something, right? And anybody that does like vape, anybody that vapes, blow your smoke into that container, and then
Dude.
put like I don't know, some sort of smooth
Just
sphere
stop.
in there.
Just stop. Just stop.
Attached to
Just
a.
stop.
Listen, I'm giving you.
Just
I'm
stop.
giving you a way.
Just stop. I said on Earth, where can I look see this happening? This process that you're saying is happening with the Earth and its atmosphere right now. How can I witness it?
That's what are you?
He's demonstrating that, I believe.
What exactly?
I'm not asking for a fish tank demonstration. I'm asking for where can I go out and see it? Do I need a microscope? How can I detect that the Earth is pushing the
you're
air in
asking-
lockstep with it?
You go outside and you're not hit with 1,000-mile-an-hour wind going the opposite way.
So the absence of a 1,000-mile-per-hour wind proves your model of the Earth and its lockstep atmosphere. Is that what you're claiming now?
So there's a really easy way to go about
this. You're not.
I mean, you got to add that to the list right there, Brandon.
Well, I'm sorry. I thought that this fish tank example was an example of how at least atmosphere does move along in lockstep.
Moyak, you.
I was giving.
Moyak,
wait, let me finish. I was giving you a way
I
that you
tried to
could
say this
demonstrate
earlier.
how
No,
a
I tried to say this earlier.
can rotate gas.
Okay, Moyak, you did not show anything. All you did was explain. You didn't show anything.
No, I demonstrated because you know it's true. I mean, we all know that. If I spin, you really think that if hold on, seriously, no, don't let me finish. So you think that if I spin a sphere inside of a fish tank, the air will not start to take up an imparted rotation from that?
No, that's what you said earlier about the container spinning along with your implement. That's what I'm saying you didn't show. You didn't show
have
that.
you ever taken a paint bucket and like put a stirrer in it, and when you start spinning it faster and faster, all of a sudden the bucket starts to spin?
I can understand what you're saying conceptually.
So if I put this on an air hockey table and reduce my friction near zero, it will spin along with it. A little bit.
What are you talking about now?
Now try that without some kind of physical object that's held in the air.
What he's saying, hey Jeremy, what he's saying that if there's a tornado, the tornado is going to start having some influence on the way that the Earth is spinning.
I mean, none of this shit he's saying is analogous. None of this shit he's saying is analogous to gas rotating with a solid object.
I just know it is exactly.
I just gave you a demo. I gave you a way you could test it. So.
Well, you want me to test your claim? That's what you want me to
Incorrect,
do?
because you have a radial
I can do
pressure containment,
You want me to
which
test
is
your claim,
causing an
Bebo?
equal and opposite.
No, you don't have to do it. I mean, you're not going to do anything
There is
anyway.
actual.
Why don't
variables
you do it?
that
It's your
you
claim
could
that it's
do.
happening and that it can happen. Why
I
don't you actually
I could
show
give
it
you a
to
way
your
to do it.
claim?
You could test it for yourself, but of course you don't do any tests. So.
Well, I'm not making any claims that this shit happens. I don't
Right,
think it
you don't
exists.
make any-
You want me to
right.
prove? You want me to
Never-
prove it? You want me to prove
Right.
non-existence?
You never make any claims.
No, do
Jeremy,
a time
right.
test.
You want me to prove non-existence, B-ball? It's dumb.
So you
Do a
actually
tire
believe
test.
that I'm wrong,
Can I
and
explain
that the air will not move along with it, and it won't introduce any torsional force on that chamber.
That's not what he said, Moyak.
Jeremy, that's rich if you're saying. Jeremy, that's rich if you're saying no, you want me to
chamber.
prove non-existence. You constantly are trying to ask me to do that with a gas pressure without a container. You're saying prove that there is no container.
No, I said prove that you can have
Wrong.
gas pressure without a container, because I don't think gas pressure without a container is something that exists
So
in
you're
reality.
asking me to prove non-existence. Prove there's no
No, it's
container.
not.
No. I'm the one who's claiming.
No, he's not asking you to prove non-existence. What he's saying is your claim is that gas pressure without a container does exist. So you need to prove that gas pressure without a container does exist. Otherwise, it doesn't.
Without a container is proving non-existence. I don't think you're listening.
Okay,
to the words.
hold on. This is exactly what I went through several weeks ago.
Because
the
they
without
contain-
container absolutely does not make it a negative claim. It
Yes,
can't.
it is. Without, all right.
No, it
it's
is not.
without. Just
If you
without
think
it
it is,
not
you're retarded.
Listen.
Not
be
when it's
quiet.
coupled with something.
If you change that part of the statement, it does not give you an absolute reverse of the statement. It gives you a different statement entirely. Therefore, it cannot be the negative.
Yeah, RC, you're totally wrong here, dude.
Is without.
You're totally wrong.
Yeah,
But when you have two components and you're only minusing one, you're still left.
They're working
Asking
from
for
the
gas
outside
pressure
in.
without
Like
a
to be
container
able
is
to
asking me to prove non-existence.
No, it's
They're
not.
working from the
No, it's
outside in.
not.
Scientifically, they're trying to work from the outside in. You don't work from the outside in because you're begging the question that we're on a fucking spinning ball with a vacuum around us. You have to work from the inside out. Show us some
We are on
evidence.
spinning ball without a container.
All their shit is step one.
But really, you're
assume the
asking
Earth
me
is
to prove a
rotating
negative.
ball.
You guys don't. If you don't see
he's
that,
not.
then you're blind to what you're
Listen,
saying.
if he's going to keep claiming that, you should just mute him. He's mentally retarded or he's dishonest or something. There's something wrong with him.
RC. All right, hold on. Let me see if I can clear this up.
Very clearly.
RC, your claim is that gas pressure without a container exists, correct?
No, my claim is there is no container because I don't observe a container.
It's the same fucking thing, man. What is wrong?
Come on,
You're
man.
breathing, though. You know, you're
So
breathing.
your claim is.
Your claim is the
His claim
positive
is the
one. There
container
is a container.
is the container is non-existent. There you
You're
go.
saying prove the non-existence of this container. No.
No,
No, that is not what we're saying. You're being a sophist right now.
No, it's not. That's
Brandon,
literally what
Brandon,
you're
go
asking
ahead
me
and
to do.
pull up that stream from several weeks ago when I went through this step by step, and I told you
No, and
this
you
seems
were
like something
completely
they're going to
wrong
start
then.
trying to do. This seems like something that the Globers are possibly going to start bringing up and trying to use against you. So I went through it step by step and explained very
you were wrong
clearly
then.
that it is absolutely incorrect to make that claim. If you
It's
say
not a claim. You are making the claim.
Listen, shut up. If you make the claim that hairless gerbils do exist, the hairless part does not make the statement negative. It is still a positive claim. Hairless is just describing the gerbil. That's it. That's it.
Oh no.
If you say blue gerbils exist, it's still a positive claim. Hairless and blue are the same thing. They only describe the gerbil, not the situation.
Great. You are claiming the container.
No.
No, it's
No,
antecedent to gas pressure.
We're just saying what we see all the time. In human experience, we see gas pressure with a container. It needs a container.
And
Your
I
claim
do not see a container around the atmosphere.
Your
Well,
claim
people
is
just give an example with a container where there's pressure being applied
No,
on the
I
opposite
observe
direction.
no container.
You don't observe
Does
it.
everyone else remember when I
You
walked through
observe a
this step by
magnetic
step
field.
and said that they
Yeah.
might start trying to use this?
Bob, absolutely.
Yep.
That was a great presentation. I absolutely loved it. I thought it was hamsters. It was gerbils, though, and that was excellent. Yeah, you broke this.
I agree.
You
it
broke
was
this
good.
whole nonsense. Yeah, you broke this nonsense. RC is saying down perfectly.
No, absolutely not. You didn't prove it then, and you're still trying to get me to prove a
No, he
negative
did.
now.
He did.
Well, it sounds like you're admitting that
completely
your claim is
logically
actually
broke
negative.
you down.
Well, first
So
off,
do-
if you depends on what you want to call a container. We do have a container, and that's claimed. But
It's like, don't ask me to prove my negative claim.
all I need is a force. So, like, you need a dome. All I need is a force. And I can
No,
demonstrate
your
force
container
propelling
is
gases.
your container is gravity.
So let me just break out your claim right
So is
here.
gravity the
Without
cause or
means
the effect?
doesn't
We know
without means
gas,
doesn't
gas
exist with
pressure,
this thing.
but it's not
No
the container
container
exists.
exists.
He's still trying to argue the without that part. You're so silly, RC.
Get rid
Stop.
of this idiot.
Do you not literally say without every single time?
RC.
Yeah, so if I
We-
say gerbils without hair, if I say you can't have a gerbil without hair, that's still a negative claim. And whoever's
Jeremy, you just caught yourself in how stupid that sounds. I heard you catch yourself with how stupid that argument is.
No. He had to make sure to say it right because it can become confusing when you're talking about negatives and positives.
He just realized that it is.
You got to
true,
make
he's
sure you
trying to
say
prove
it
a
right
negative.
with negatives and positives, unlike you're doing. You're doing it wrong, and he apparently wanted to do it right instead of stupid and wrong like you.
Oh man, you guys really.
I actually think about what I'm saying sometimes. RC, I actually think about what I'm saying sometimes. And your whole argument with this, I'm making a positive claim by saying
calibrate a water level.
Are you, Jeremy? Are you not making?
Kango 24, $5 New Zealand. Sorry, did I miss the show when you approved all video and pictures from space are fake? Because we have video of the Earth rotating. Yeah, I got a video of superheroes in a gigantic battle fighting each other to the death. So, yeah.
Claim, and you
yes,
are
that's
claiming.
a negative. It's called a negative claim.
So you want me to prove a negative? There you go. Good job,
that's
Jeremy.
a perfect claim to have.
Anyone taking the opposite. Hold on, guys. Guys, hold on one second. Anyone taking Anyone taking the opposite. Guys, please.
I knew you'd get there eventually,
never
Jeremy.
mind.
Good job.
I fully back that statement. Henry.
How am I gonna? How can I respond when you guys are like animals over them? Now listen, that is a negative claim. Anyone taking the opposite position on that and saying, wait, gas pressure without a container does exist. The burden of proof is on them because that's a claim of existence. Mine is a claim of non-existence.
No,
Jeremy,
it's
do you believe there is a container?
Why are you
do you
laughing
believe the
like an
atmosphere
idiot?
has a container?
It's natural law.
Jeremy, do you believe the atmosphere has a container?
We have gas pressure on Earth, and since we know that you can't have gas pressure without a container, there's absolutely a container. Yes.
Therefore, hold on. Right, so there's a line of logic you've got there, and it ends up being necessarily the existence of a container, doesn't it?
No, wait, hold on. Not
If
as
you
a
want to
claim,
have
though.
gas pressure,
Oh,
it is.
look, he's delivered a line of logic, and the line of that logic he ends up with there necessarily being a container.
All you got to do is show me gas. All you got to do is show me gas
Yeah, I know,
pressure
but
without a
but so
container.
your
and
claim
hold
is
on, Rumpus, I
you've
was
shown a
talking,
line of logic, and that line of
No,
logic
we're not
says
doing
there
it.
must be.
No, wait, hold on.
Guys, I
explain why
server
you're
muted
wrong.
him so I can respond. Whatever. Go ahead, guys. Go ahead. I'm home with my family and shit. I can't be wilding. I can't be wilding right now. So
This is such straightforward idea. This is such a straightforward idea that you are claiming there's a container, right?
Nope.
And then you're asking me to say, prove there's not a container.
Nope, not doing that either.
would've-
You're wrong on both counts.
What is
So
the
you
container?
don't believe, so you're
All
not
you have
claiming
to
there's a
do-
You don't
container?
need to prove anything. You
Jeremy,
could
the
just
conclusion
fall
of
back
your
on natural
reasoning,
law,
Jeremy,
law of
the
thermodynamics.
conclusion
You
of
don't
your
have to
reasoning
prove
is that there is a
anything.
container, isn't it? Your reasoning leads you to the conclusion there must be a container.
Nope. Here, I can explain it very carefully. He has stated a logical
There's some
statement.
selfish motherfuckers.
Yes, the conclusion of which is there must be a container.
The conclusion that you come to based on that logical statement is your problem, not his.
No, his logic necessarily leads to the existence of a container.
That's your conclusion from his
No.
logic statement.
No,
If that's the conclusion you come
he's
to,
just not.
you
He's
have a problem,
dodging his
not
own
his.
conclusion. He left a line of logic,
That's
and the
your
only conclusion you can come from his
your
line of logic
problem, not
is
his.
there must be a container. His
All right, that's
logic
your
leads to
conclusion,
that
and that's your
necessarily.
problem, not
If you
his.
don't understand how logic works, then that's your problem. The logic
So proceed anyway.
leads
That's
to
what
the
we asking.
conclusion
How
there
hard is
must
it to just say
necessarily
yes?
be a
Yes,
container.
Why you butthurt?
There is
Let
one-
Jeremy
hold up.
answer.
Hey, there is one question on the table,
I wish
right?
Jeremy
One
would
question
answer.
and one question only, right? Is there a container or not? There is no evidence for a
Let me start
container.
over.
The answer
me start
is
over.
there's no evidence
There's
for a
gas
container.
No, I'm
pressure.
not gonna never.
It's natural
Jeremy,
law.
is there a container?
Go ahead, Jeremy.
I can't talk
Go
to
ahead.
people. I can't talk to these guys right now because
Yeah.
it's too much, bro. Our own people, them guys. It's all out.
Jeremy,
Go ahead.
is there a
Now listen,
container?
here's
Yes
my
or
line
no?
of logic. You can't
Shut
have.
the fuck up, Rumpus. Go ahead, Jeremy.
Well, he won't answer the goddamn
Can you
question,
have-
will he? He's obfuscating like crazy.
Okay,
Nope.
since we can't have.
You know why?
I'm obfuscating. I haven't got a chance to talk because it's got people like this and you and RC. Now,
Because you're dodging
here's,
it
here's my
again.
line
It's
of
a
logic.
simple question. Do you?
Go ahead.
Here's my line of logic. If you
I'll
now,
meet you in a minute, Rumpus.
since we know you can't have gas pressure without a container, right? Does anyone refute that first part? Because that's where what you would have to do to stop
That's a
this.
claim, Jeremy. That's not a reality. That's a claim.
No, that's natural law.
No such
No,
thing.
there's
Since
no
we
natural
know,
law
since we
that
know
states
that you
that.
can't have, since we
It
know
is.
that you can't have gas
Sexual
pressure without a
thermodynamics.
container. Go ahead, Arwen. You got it.
Quote
Oh,
the
yeah.
natural law. Hey, hold up,
Jeremy, you stopped at the
hold
last
up,
minute
hold up.
there. Finish that
Hold up.
sentence, Jeremy.
What is
Finish
the
that
Since we know you
sentence,
can't have
Jeremy.
gas, I can't because I can never get a whole sentence out, Rumpus.
What is the natural law that states?
Oh, let
what
him
you are
finish,
claiming, Jeremy?
RC. Let him finish.
Now, the first part of the logic would be, you can't have gas pressure without a container. Therefore, right? Does anyone disagree with the first part of that?
That's irrelevant. We want to
Therefore
go to
what?
the eventual line of your reasoning. It's irrelevant whether we disagree with the first bit. It's your
And we have-
logic, not ours.
And we
Therefore
have
what,
gas
Jeremy?
pressure on Earth. Okay, you can't have gas pressure without a container. We have gas pressure on Earth. That would lead you to believe what?
We're talking
I
about
don't
your
know,
logic.
you tell us.
Logically, where would
We're
you
talking about your
take
belief.
There is a
We're talking
container.
about your logic.
There is a
Jeremy.
container. I'll
We
just say
want the
it.
necessary
Let's get it over
conclusion
with.
of your logic.
Logically, you would take it to that there would need to be a container. I don't know.
Yes,
That's what I would take.
exactly. Your logic
Thank
leads you to believe the existence.
Well, where
of a
does that
container.
logically bring you to?
Because it's bollocks the bit about being requiring a container to have pressure.
Ah!
Utter drivel.
Really, show the formula. Show us the formula then.
I know that's funny, right?
Right, so
Show us the calculation
but
for
your
gas
premise is
pressure, Rumpus.
wrong.
Show
But
us how
nonetheless,
it's
your logic
calculated.
leads to the existence of a container, and we can show that doesn't exist. And
Well,
we know
then
that
show
you
us the
can't
gas
have
pressure without a
How you
container.
calculate gas pressure, Rumpus? Show us how you calculate it.
You just headbutted me, my
Does it involve
You are the
container walls?
I can't hear you, Arwen. You're being overtalked so much.
Guys. Hold on. Earth is life. Your mic is sucking right now.
Can I actually
I was
respond?
hot micing too. My bad.
No, hold on. Rumpus, you just made a claim that you can have gas pressure without a container.
Correct.
No.
Okay. So show us.
Yes, I did.
Why
I see
You
it
can't
in
even
no.
calculate gas
So
pressure
support the
without a
claim.
container.
Support the claim.
Right.
Rumpus said yes, he did, and RC said
Yes,
no. I
I
don't
did
know why
make the
RC
claim.
said
Yes,
no.
you
I don't know why
can have
RC
gas
said
pressure
no.
without a
but-
container. Yes, but we were talking
his
about Jeremy's logic, and Jeremy's logic necessarily concludes with the existence of a container. But I also making the claim, as a separate issue, that you can have gas pressure without a container. But we were worrying about
Well, can you
Jeremy's
not
logic
support?
there.
You
What's
can't
the
even
problem though? This
calculate
this
gas
was all
pressure
an
without a
objection to Jeremy RC Meisty not wanting to support that claim, saying he didn't make a claim. You're saying yes, you are making a claim. Can you support the claim or not?
Well,
Brandon, all they have to do is show us the gas pressure without a container, and there's my
No,
logic
That's
out the
it.
window. I'll be made to look like a fool.
Is show us. No. All you have to do is show us how we can detect this container, and is it
No.
a solid?
No. Clearly, you weren't paying
Why am
attention the last 10 minutes.
why am I being talked over? Like, I didn't say no because
You
I
weren't
disagree with
talking.
Rumpus. I'm saying no because, hey, I've been
You're being
trying to
talked
freaking
over
say
because
something.
we can't see you. You're only 2.5 feet tall and you sound like a gnome.
Yeah, you
so
like to
all
talk
you have
over.
to do-
Don't be so rude. Don't be so ill-mannered, Travis. Let him finish his sentence.
I'm only,
Oh, that's
I'm only,
rich.
I'm only a
Coming
foot.
from you.
From a fucking gerbil.
I do. I let people finish.
All right, that's what she said. So
All right.
here's my point. Okay, the question is there a container or is there no container? right? That is the question.
No.
There is no
Well,
evidence
logically,
of a container. No.
if you
Hey,
follow
we're
the
not.
if you follow
Hey,
the logical
stop.
path
There
I
is
laid out for
evidence
you,
of a
Shut up. I
container.
let you talk for 5 minutes straight. So shut
Oh,
the hell
let
up.
him finish.
So the question is there a container or not? Done. Screw the logic. Screw everything else. What you think
Screw
is
the
natural.
logic, we know.
No,
Screw the
shut up
logic.
for a second. Shut
Jeremy,
up.
you're
What are you
interrupting
doing,
him
man?
now.
Would
You're
you
doing
shut
exactly
up?
what you were complaining about.
Because now they're talking gibberish. What do you mean screw the
Shut
logic?
up,
Yeah,
Jeremy.
he hasn't been
I
able to
let you
finish a
talk for 5
sentence.
minutes straight. So the question is there a container or not? The answer is we have no evidence of a container. Period. Now, if you'd like to present evidence of a container,
All right.
go right ahead.
When a server
There you
brings
go.
you a big steak, hold on, Arwen. When a server brings you a big steak, you go out to dinner, you order a big steak. Do you need to see the cow, or do you know that a cow exists?
We're not talking about steaks, Jeremy.
No, we are. Well, I am.
No,
talking
you
about
need to see
you
the
need to see
cow.
the cow.
You need to see the cow. Yes, because steak
You
can
need to
come
see the
from
cow.
very many different. No, I want to talk. No, you don't tell me when to talk. Sorry.
Stop with the analogies.
No.
We're not
So,
doing analogies. We're doing
you don't tell me what we do.
I want to
You
know
don't
what
tell me
happened to
what we
this
do,
cow
RC.
now.
I
What
let you
happened to the
talk. You let me
cow?
talk.
Like and subscribe, everybody. Like and subscribe.
So,
Subliminal
yeah, like and
messages.
subscribe.
Like and subscribe.
Freedom for Chikey.
And donate.
Freedom for Chikey.
I'm asking for evidence.
I don't care. RC. I let you talk. You let me talk. So yes, Jeremy, you need to see the cow because steak can come from various different animals. Okay. Don't quote QE on his stupidity.
This is not stupidity. It's a lot.
It
It's a
is.
necessary
It is.
antecedent. If you have a
hold on.
filet mignon,
You're trying to logic your way to evidence. Evidence is something you can observe, measure,
You can break-
or freaking look at and touch physically.
RC, you can
Exactly. The
RC,
things
you
you
can
can't
break my
do-
you can break my chain of logic. Hold on, B-ball. RC, you can break my chain of logic. All you have to do is show us the gas pressure without a container, and then my logic will be all flawed and it'll be obvious.
No, all you have to do is show us how we can detect this container.
So, Jeremy, I don't have to provide you
Magnetometer.
evidence that something that doesn't exist.
Yeah, your my negative is your positive claim, though, RC.
No,
so
Jeremy,
what do you mean you don't
I
have to provide evidence of my negative?
exist.
It's your positive claim.
I don't have
You know, half your model, RC, is based on logic like this, by the way, RC. So you guys just got done telling me that that the Earth. You just got done telling me that the lockstep atmosphere is a thing. We know it's moving in lockstep with the Earth because there's not 1,000-mile-per-hour winds.
I didn't say that, Jeremy. Brandon, I didn't say that.
You didn't say the 1,000-mile-per-hour wind? Who was that?
Somebody, it might have been B-ball, but somebody did just use that logic on you. That since we go outside, hold on, RC. Since we go outside and don't see 1,000-mile-an-hour wind, therefore the atmosphere must be moving in lockstep with Earth. That is the logic they just used.
Correct. Yes, absolutely correct. We know that the Earth rotates 1,000 miles around the equator. There are still days at the equator. Therefore, the atmosphere must be rotating with the Earth. It's simple.
All right.
Simple logic.
Gas doesn't retain momentum. It can.
Of course, it does. Everything does. Arwin. It's a fundamental law of physics that everything retains momentum.
We're getting a little out of control here.
That up, Arwin. You've just made
Hold
that
on,
up.
hold on, everyone.
You've just made that up.
Have the
everything
bond
retains
to
momentum, Arwin.
provide
It's a fundamental law of physics that everything retains momentum. There's a conservation of momentum, including gases. They're just very small particles. There's no difference. The physics that it takes gas is no different to that of solids in the way momentum and energy. You're an idiot.
No,
Yes,
it
it
doesn't.
is. Yeah, Rumpus, but a tornado
gas
is
only
gonna
responds to
logically
local air pressure differential. It doesn't retain momentum. It doesn't have inertia. No,
How much
doesn't.
better
It only
you will work in
moves
Gas
in
has-
accordance to
How do you
local air
think
pressure
wind blows on
differential.
you, Arwin?
Guys,
That's momentum.
guys,
The pressure on your hand
Rumpus,
when you
you're
stick it out
number
of a
one
car
on this one,
window
you
That's
guys.
is
local air
momentum of the
pressure
air.
differential. The air doesn't actually
Arwin, I
retain
have a
momentum.
plan.
It only
Arwin, I
moves
have
with
a
the
plan
body
here.
of air because
You're
of air pressure
denying wind.
differential.
You're denying
No,
wind,
I'm not
Darwin, you
denying
silly
wind. That's
person.
also local
All
air
right.
pressure.
I can't
We
even.
can't hear you guys because you're talking over each other. Let's just slow it down.
Yeah.
Can I just say, Brandon,
I have to
happy
yell because every
150th
freaking
show,
minute
mate.
Discord just zones me out.
Thank you, Gleam. We should let RC Meisty respond.
So, what I was saying earlier is that because we have this question on the table, is there a container or not? We don't even have to argue about the question. It is just simply a freaking what is statement. What is statements? You don't have to get to a logical conclusion with this, with like logic your way to a conclusion with a logical syllogism or something. You simply have to say, is there evidence for that thing as you're defining it? Is there evidence for a container or not?
Yes, there is. Yes, there is.
There is
Right.
none.
Okay. What is your
In fact,
evidence
we've
for the
validated
container?
it. In fact, there's contrary evidence to it.
No, hold up. Who said yes? And tell me what your evidence is.
I did. Because we have three things that are not possible without a container. Within the globe Earth claim, we don't only just have gas at pressure that's contained by a supposed force. We also have two other things that require containment, which is temperature and vacuum. Now, there are three things that we know for certain in the world we live in, the 3D world we live in, that you can't create and have without a container. So that's not
You don't need a container. You just made that up. You do not need a container. You just made that up, Brian.
No, I didn't make anything up.
You just made that up.
Rumpus, you're not going to get away with this bluff,
What do you
man.
think gravity
Nonsense.
exerts a force on molecule gas, just like it
Doesn't
exerts a
make
force
gas
on
retain
you?
Rumpus. Rumpus.
Gas is subject
Hold
to
on.
gravity, just like you are, and that's why
Let's
it's
let
down, and that behaves. Gravity acts
let's
like
let
a container.
let's let Rumpus and Brian go back and forth for a minute, just so. And then
Right, let's make it
we'll
clear.
bring you in.
A container exerts a force on the gas molecules, so does gravity. So gravity acts like a container. You can imagine all these little gas molecules with little springs on them being pulled to the center of the Earth. They're just like bouncy balls that are just as they drop to the ground, so does gas molecules, and then they bounce up again, except they're going at 500 meters per second, so they bounce up really, really high. There is a force acting on them, so they can't escape. It acts like a container, and we have evidence there is no container because we've shot things through the space where this container would have to live, and we know that there's nothing that contains them. So we know not only that there is not a container, we've evidence that there's not a container, just not there's an absence of evidence for one. We have evidence that there isn't one. Finished.
Okay, now I go. If Rumpus could leave me, I left Rumpus get his thought out. If Rumpus could leave me respond, that would be good. Okay. So what you're essentially doing is you're taking the PV equals nRT, and you're taking the T away and adding in a G, right? What you're not doing, right, is you're not showing any physical demonstration of either gas pressure, temperature, or vacuum being contained, or sorry, without containment. There's no demonstration in the real world of any of these things. You have a claim of a force of gravity, which in your pseudoscience world is out of date by 106 years. It's not even claimed to be a force anymore. I already had you personally. Like, you're like, if you can, I don't care
how long how many points are you going to make, Brian?
I let you finish. Right?
Well, I think you've gone for 2 minutes.
I don't care what the claim is. All you have to do is physically demonstrate it. Because by pure logical inference, right, we know that we can't have any gas at pressure, temperature, or vacuum without a container.
Yes, we can. You just claim that.
Your claim is that it exists without a container. Right?
You're just making a claim. You have no basis for that.
I have you won't let me finish. What's wrong with you? You seem to have a problem.
Well, how long are you going to be?
So, have I finished? I'll take as long as I need, as long as you keep on.
Okay, so long as I can take as long as I want, then. Okay, so long as I can take as long as I want.
Right? So, if you're claiming these three things, then you've got to show them with physical demonstration in the 3D world.
Okay, I will.
Right,
so it's now my turn to respond. To that.
There was no point in pointing to the sky and claiming blah, 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 and gravity is a force.
Right, can I answer your point?
That's just
can I answer your point?
Logic, Wampus.
You've now
I
made the
can't
same point
blame
3
you for
times,
the fact
and now
that
you're not
you-
letting me answer.
All right, Brian. Let him respond now.
You're not letting me finish.
Right.
Brian,
So
you
this
never let me
PV is equal to nRT requires a container, but the atmosphere does not have a container. It expands. So this PV is equal to nRT, which is a formula that Brian doesn't understand, is not
Hang on, that
relevant
was an
to the.
ad-hom there.
No,
That
shut
was an
up! Shut up! It's my turn. God, that was about 10 seconds of
that
you
was an
interrupting me.
ad-hom there.
Shut up! Shut up! It's my turn. So PV is equal to nRT is only relevant to something with a container. The atmosphere doesn't have a container, so the PV is equal to nRT is not relevant at all. He, for some reason, seemed to think that T. Shut up! Shut up! I'm still responding to 3 points you made, and the T he just made. Shut up! It's my turn. It's my turn. I'm answering your 3 points. Shut up! You've had 2 minutes. I've only had
Guys,
about 30 seconds.
come on. Brian,
Jesus Christ! Brian, shut up!
Calm down, Rumpus.
And then he made up this PV is equal to nRT and thinks that somehow G replaces T. T's got nothing to do with this. He's trying to apply the PV is equal to the ideal gas law equation to something it does not apply to. So he's getting utterly confused. Gravity is a force. Einstein said he completely agreed with Newton's interpretation of it being a force. In simple conditions where you do not near a black hole, you're not moving at the speed of light. And what's more, the Einstein equations reduce to forces in a 3D world. And Einstein never contradicted Newton. He specifically said his thing does not supersede Newton's law of force of gravity. So to claim that it's out of date, it's not. We used Newton's laws all the time for the Apollo space program. Etc. And anything else we do in space. So every point you made was utter science-denying drivel. Go ahead.
No, I now will respond. So what you're after just claiming there, if someone has the mic open, maybe on purpose, I don't know. What you're after just claiming there is that convection happens due to gravity and not temperature.
No, convection is
due
to less.
Hang on a second.
Well, hold on. Let me answer. You've just come up with a new point. You've just come up with a new point. You've just said that, and you made a claim that I said something, and I haven't. You've just strawmanned me.
Hold on,
He
Rumpus.
just made a claim about what I said, and I never made the convection.
So what? You made a lot of
said.
claims during your speech. Let him go.
Yeah. Right. Rumpus claimed that PV equals nRT only applies to gas that's within a solid container. Right. Now, he claimed that there is no solid container for his atmosphere. That means convection has to be caused by gravity or some other force and not temperature.
Not at all.
That's
Who said
exactly
that?
what you just said.
Where'd you get that from?
That's you. It's from exactly what
You've
you
just
said.
made that up. You've just
said
assigned to me something I've never ever said, and no, science doesn't say that. Right, I'll explain to you what convection is. Let me explain to you how convection works.
We don't need
But I'm
explanation
about to
of
tell you how it works because you're confused. My turn to speak. You've just made a claim about convection, and I'd like to respond to it.
I didn't make a claim about convection.
You've just made a claim about convection.
All right.
You've
Go ahead,
ascribed to
Rumpus.
me. I've never made that claim. He's ascribed to me a claim I've never made, and I'd like to respond to that claim.
Go ahead,
he's
Rumpus.
ascribed to
Respond.
me. Right.
Respond.
Right. So here's how convection works. When something becomes hotter, it expands and becomes less dense. And in a gravitational field, the more dense objects are attracted and displace the lower dense objects. So convection occurs as a result of gravity. If there were no gravity, there'd be no convection. But it's caused by a change in density of something, and that means that that's the result of temperature. So what his point was, I do not know. He doesn't understand density, he doesn't understand convection, and he doesn't understand the effect of gravity causing buoyancy effects, which is what causes convection. Go ahead.
So, Rumpus, you claimed that PV equals nRT does not apply to gas pressure that is not under solid containment. That was your claim. That means convection doesn't happen.
No, but that's a different thing. Convection and what you've just described are two different things. PV is equal to nRT is a completely separate issue to convection. You've decided they're the same thing. They're not.
Rumpus, you cut him off. Let him finish. Go ahead, Brian.
Yeah. Thank you, Brandon. Because he's making a million claims and using a lot of add-ons here, right? He's not supporting any of this. Is convection
just science?
Is convection caused by temperature differential or gravity?
I've just been muted. Right.
No, you're not.
It's a combination.
I did ask.
Hold on, I was muted. I can hardly respond to you if I'm muted. Right. So, the convection. I went through this about 1 minute ago. I explained to you how convection works.
No, you didn't.
Oh my God! Right. Right. Here we go.
He did ask you a direct question. Rumpus, he asked you a direct question though, this time.
What's the direct question?
Say it again.
I'll ask again, Ron. Okay. Is convection caused by a temperature differential, or is it caused by gravity?
It's caused by both. Well, it's actually caused by density
not.
change. So here we go. I'll go the reason. I'll explain the reasoning slowly and carefully to you. Here, I'll explain to you slowly. Here's my answer. I'd like to answer. I'd like to answer. Stop ascribing to me what you think. Can I answer, please? Right.
Go ahead.
Here we go. So here's how it works, convection. As I said, but you obviously weren't listening. An increase in temperature causes a change in density. It's the change in density acted on by gravity that cause a buoyancy effect. So convection is a buoyancy effect. That's a combination of a change in density and gravity. The change in density is caused by a change in temperature. So there's a sort of chain of effects here. So we have an increase in temperature, that changes the density, and then you have a buoyancy effect caused by gravity. That's the chain of effects. Finished.
Okay, Brandon. Earlier, Rumpus claimed that PV equals nRT, T stands for temperature, does not apply to his model where gas is under pressure but not contained by a solid container. He said it doesn't apply to when gas is not contained by a solid container. And now he's trying to apply temperature.
There are different equations. Not all equations are covered by PV is equal to RT with temperature in them.
Let him finish.
And we haven't even gotten to the gravity claims yet. We're going to get to them.
Right, you seem to think that the only thing that temperature ever does, involves itself in, is with PV is equal to an RT. Temperature does lots of other things.
Never said anything like that.
It also, for instance, determines the kinetic energy of the molecules.
Yes,
there
I
are
know
many things. Hold on, there are many things that Shut up, I'm still answering. There are many things. Shut up, I'm in the middle of answering. I'm in the middle of a sentence and you're interrupting me. Shut up, moron. Shut up, Sans denying moron. I was in the middle of a sentence.
Guys.
Right,
Rumpus, hold on.
Yeah, but he keeps on interrupting me. He does this systematically as a deliberate policy to try and disrupt the... He's doing it again. He's doing it again. He's not letting me finish my sentence. I let him finish.
Hold on, Brian. All right, let me talk to him for a second. Go ahead, Brian.
Yeah, Brandon, he's trying to just give us some ad hoc explanation for...
What happened? Brian, you there?
What should have happened?
You just lost audio.
I'm there. Hello?
Oh, yeah,
Hello,
we couldn't hear you
Brandon?
for a second. Go ahead. Yeah.
I don't know. Maybe I got muted or something by someone. No, he's trying to give us some ad hoc explanation of how temperature affects gases and gas behavior. But he already claimed that temperature plays no part within his model. Earlier,
I didn't say that, you uttermoron. I said PV is equal to nRT doesn't apply. That I did not. You seem to think that PV is equal to nRT doesn't apply doesn't mean that temperature doesn't apply. He's ascribing to me again something I've never said. Temperature does. I described to you twice now how it causes convection, but that's separate from PV is equal to nRT. You seem to think that the only thing temperature can do is participate in PV is equal to nRT. It participates in lots of things, including the change, as I described its effect on density. I described to you specifically how convection works. There's a change in density caused by a change in temperature, and the change in density acted on by gravity causes buoyancy effects, which causes convection. So I've just described to you how temperature is involved in that. PV's equality is not involved in what I've just described there.
Now, I never said what's going on here now, Rumpus, is you're trying to strawman me. I never said that temperature only affects gases or anything else like that. You made the claim that within your model, right, that gas is under containment without a solid container, and you claimed that PV equals nRT only applies to gas that is under containment by a solid container. Right? That means there is no T in your claim. That is the end of that. You've ruined yourself.
Where'd you get that from? Which claim are you talking about? Which claim of your mine are you saying is invalidate? I'm saying it has got no T. Which claim of mine are you claiming invalidates the behavior of temperature having no T? I've described a sequence to you 3 times how temperature is part of my model. I've described to you 3 times how temperature is part of my model
Rumpus,
and causes
do you have a
convection.
question? Do do you have a
Well,
do you have a
he
question?
won't let me finish. He's just claimed that somehow, I don't know where he got this from, that somehow temperature does not get involved in the globe model. Yet I'd said 3 times, I explained how convection works, in which I described how temperature works in it. So how he can claim that I'm denying temperature's involved in this process, I don't know. I've given 3 times a literal description of how temperature is involved, and he's saying, no, Rumpus is saying temperature isn't involved. I mean, what the hell's this guy on?
Rumpus, you claimed earlier that PV equals nRT, right, has no place, right, when gas is under pressure, within your claim of gas under pressure without a solid container. And now
Which
you're
has
trying
got nothing to do with the explanation I gave of convection.
claim, when you already claimed that the whole gas pressure gradient is caused by gravity.
Yes.
Right, that's not caused, that means temperature plays no part. Right, you already.
Now we're talking about something different. We're talking about. Hold on. Now you're saying temperature plays no part in density gradient. You've now changed the subject. You've now said temperature plays no. You've claimed that I said that temperature plays no role in the density gradient. He's made up. This is a new subject. He's just changed the subject now. He's now introduced the concept of a gradient. We never mentioned that before, and now he's saying that I said something about the temperature gradient or the density gradient or something. We've never discussed this before in this discussion, and now he said that I've been making this claim. Where the hell is this guy getting it from?
All right, let's wrap this up. Let's make
T and insert a G. You said take away the T and insert a
He talked about a
G.
gradient of something, and we'd never discussed a gradient of something, and then he said that I said something about the gradient. I never had.
We are
Jesus
discussing
Christ.
gas pressure within our air, are we not?
Yes, we are. We are indeed doing that.
Air under pressure, yes.
But we never talked about gradients, did we? You brought that up, and you said I'd said something about gradients, and I had not.
You already brought in gravity. Sorry, you already brought in density into it earlier. When you started claiming gravity.
Yes, we never talked about gradients, though, did we? We never talked about gradients, and you said I'd said something about gradients. I never had. You made that up. You just made that up.
All right, hey, listen, Brian.
Brandon. He ascribed to me something about gradients.
I understand.
I never mentioned it.
I understand.
Are you going to
I
complain
got you.
about
So
that for the next half hour?
Well, he
let's
keeps on
let
claiming I
these
did. He
guys
keeps
make
on
their
not
final
accepting that
statement.
argument.
God damn it, Rumpus, shut the fuck up. Brian, hold on.
I wasn't talking. Arwin was. It was Arwin who was
Make
talking.
your final statements on this subject, then we'll move on because we don't seem to be getting anywhere.
Can I go first?
Go, Rumpus. Go ahead.
Right, here we go.
Don't interrupt each other during this, please.
Okay, so PV is equal to nRT is a ideal gas law where you have a fixed volume or a container. As the atmosphere can grow and expand into empty space, the PV is equal to nRT does not apply. So anything that Brian says about PV is equal to nRT is utterly irrelevant to the atmospheric situation. It's special because the gas molecules in the atmosphere are being pulled towards the Earth as though they were on springs. That's the container. That's the substitute for the container that he's getting all excited about. Gravity acts like a container, and any molecule that tries to go a long way, it can go a certain distance, just like when you throw a ball up in the air. If you throw it up very fast, it'll go up high. Similarly with the gas molecules. They're moving around at an amazing speed, 500 meters per second. So if they happen to be going upwards, they will go up very high, up to 60-odd miles, before they'll slow down, just like a bouncy ball will. If you throw that up, it will gradually, as it goes up, it's accelerated downwards, it's still going up, and eventually it will come to a stop and then fall back down like a bouncy ball. And gas molecules behave in just the same way. They are contained by gravity. Finished.
Brian?
Okay, I'm going to go to Brandon, okay? I'll make it as short as possible. You can't claim that PV equals nRT plays no part in your model and then try and claim T afterwards, because in his model, in Rumpus's model, right, the gas pressure gradient is caused by a force in his claim of his model, not the official one, is caused by a force of gravity, right? Now we can show and prove, right, that all gas behavior, right, is only manipulated by 2 things: 1, a solid container, and 2, temperature, right? And officially it's shown the temperature creates the gas pressure gradient.
Yeah,
right?
you spoke enough. Show us.
Sorry,
Show us.
I'm not finished.
Shaiki, what the hell are you doing?
He said he can show us.
Shut up for a minute. He's getting through his final thing here. Finish, Brian.
Yeah, thank you, Brandon. Right, And I even did a presentation on what causes the fact that the sun causes our gas pressure gradient, right? And within that, I used official documentation that use PV equals nRT, right? I can show at any point that gas, right, can be made to gradiate due to temperature, right? Rumpus has a claim that gravity does this. That means there is no temperature involved, and he even said that PV equals nRT plays no part within his model when he said that his model is gas under pressure within a solid container, because PV equals nRT only applies to a solid container, right? So I can show gas pressure, right, differential.
Is this you said you're going to be concise, Brian. Is this a concise version?
Just at the crescendo.
This is concise, is it?
And show the demonstration of his claim. Thank you, Brandon.
Yeah, show me one place on Earth. If you're choosing the PVNRT is indeed true. One place on Earth.
Holy shit. Kango 24, New Zealand $5. Show the container around Jupiter. It's a giant ball of gas. Is it? I don't know. If you say so, Kango.
Higher density.
Thank you very much.
Right, at the top of Mount Everest, we have a less density of gas. We also have an exact matching temperature differential.
But not in my room, no.
Yes, there's temperature differential in your room. That's
no, there isn't.
There's convection happening inside your room. You don't need to go.
The example wasn't in your room, though, Chike. No. So don't worry about it. He give you an example, deal with it.
No temperature difference.
The temperature goes up as you get higher again. It goes up into like the 30, from minus 40 up to like 30s, plus 30s. So you got a high temperature above a low temperature above a high temperature.
That's right. That's right. It does, and that's all within my presentation. It was 1 hour 37-minute presentation, and I cover that as well.
Sans denying drivel, no doubt.
As far as the PV NRT,
but what point here is that there is a claim on the table.
The PV NRT, the V is variable.
V is for volume.
V is variable. No, I mean it's volume, but the V is a variable. Volume changes.
Yes, but it's variable, Bron. Listen to what he's saying. He's saying the volume can change, you moron.
Oh, that's cool. What's the volume? So hold on, Brian. Brian, hold on a second. They have a V.
NRT is not part of your model. So you can't now join in with this guy if he's saying it is.
Brian, hold on. They got a V. What's the V then? What's the V?
The volume of the atmosphere changes.
Yeah, sure.
The volume of the atmosphere. The volume of the atmosphere changes.
If you know it changes, what's the V? What's the V? What is the number?
Well, it changes.
What's the number? Hold on a second, Brian.
It changes. There is no one number, Jeremy.
If you know that it changes, you must have known the number at 2 different points in time to where you would have known that it would have changed. Why are you guys talking over me?
Look up air parcels.
Yo, why do you guys not know how to have a conversation ever? Moyak.
We know that the atmosphere expands and contracts. It does not.
You'll have to put atmosphere.
Okay, if you know that, you would have to have known the volume at one point in time to know that the volume changes. Because if you've never known the volume, how would you know it changes?
Well, what we do know is that, for instance, so you talk about interrupting people, and you interrupted me 2 words into the answer. Then, well done. So hypocritical in extreme. Yeah, well, he claimed other people interrupting, and then in what he do 2 words into my answer, he interrupted me.
Okay.
So we know, for instance, you're doing it again. So we know, for instance, things like the ISS. We can measure where the density of because of course it's quite difficult to decide where the atmosphere of the Earth ends because it just sort of goes off in a gradual reduction. But what we do
you don't
know
have a volume. You don't have a volume then.
I'm about to. Here we go. So, well, you can. It depends. You can decide on the volume of the atmosphere depending on what you regard as the density that decides on the atmosphere ending. But what we do know is if you nearly there. What we do know, nearly there. 5 more seconds. What we do know is that the atmosphere, the density of the atmosphere, increases at particular points, and therefore we know that the volume is increasing. Go ahead.
The volume is like if you take an example of like a hefty bag, a garbage bag, and you fill it up halfway with air, heat up that air in that bag. Tell me how much the pressure will increase. It won't.
Okay, and
Because
if you want, if you're claiming that the volume changes, you must have known the volume at 2 different points in time. Again, otherwise, how would you know the volume changes?
Well, we can do that, Jeremy. But the point is, we
Doesn't
can
the
give
volume
an idea,
changing reduce the pressure?
Yes.
Right? So how does the pressure increase if the volume is constantly changing with the increasing pressure? Is it just constantly cycling through, I guess, so it's temporary?
Yeah, for instance, the temperature. If the Earth's temperature, if you get an extra hot day or something, then the more sunshine or whatever, less cloud, then that means the more heat gets to the ground. Therefore, it becomes hotter, and therefore the air expands, and therefore the atmosphere expands. It can also expand for other reasons as well, and that means that then if you go out to say 60 or 100 kilometers, where the Kármán line is something, and you measure the density, you'll see that it goes up, and that effectively indicates that the volume of the atmosphere has gone up. But I mean, you can ascribe a volume to it if you want. I mean, for instance, Jeremy, if you want, we could say that the volume of the atmosphere is the ring, the 3D space up to 100 kilometers to 100 kilometers, and then if it as the hold on.
I don't want to guess. I don't want to guess.
Jeremy, you've
You're
got to
telling me that
decide.
you...
Jeremy, where do you decide the atmosphere ends? Is it when it gets the pressure gets down to say, or the number of molecules gets down to say 10 per cubic meter, or 5? Which one of those do you want to pick on?
Well, if there's still gas, then it's still atmosphere, right?
Well, in which case, space.
So why
is,
would you
then
stop?
case,
Why
hold
would
on,
you
in
stop
which
it
case,
until the gas?
Hold on, Jeremy. Space has got 1 hydrogen atom per cubic meter. In which case, then you're saying that the space has got an atmosphere.
Yeah.
Yeah, that's what you guys say.
Arbitrarily decide.
Yeah.
Sorry.
That's what you guys say, that space has an atmosphere.
Well, we don't. We say that we say when you get down to 1 molecule per cubic meter, that's effectively empty.
But it's not empty.
Hey.
And there would still be, you would still need to expand your volume out to that point because it would still be containing more gas, right? You're going to just arbitrarily, are you going to arbitrarily leave some of the gas out of the out of this volume?
What we do, we do, we decide.
What kind of measurement is that?
Hold on, I'm asking Jeremy, you're interrupting me again. We decide that there's a certain density at which we regard the Earth's atmosphere as not as ending, and that was defined. Well, actually, we defined the Kármán line. Doesn't quite do that, but we've got to make how do you decide what density is going to determine whether you're in space or in the Earth's atmosphere? And that's a bit of an arbitrary decision because there is gas in the space. There's one, at least, even in empty, the voids of space, there's still 1 hydrogen atom per cubic meter. But we don't regard that as part of the atmosphere. We regard that as a vacuum. In fact, that's a better vacuum than we can create on Earth. So we regard that as a vacuum. So then you've got to decide what density constitutes Earth's atmosphere and what doesn't. And that's an arbitrary decision.
It's an arbitrary decision. I think that sums it up perfectly well. Yeah. So it just changes. They just decide that at 60 miles above the Earth, that's the volume, and it changes.
Okay,
even though the air, the atmosphere is expanding and contracting along that 60-mile, that imaginary border. You're just making up a volume. So there's not really a volume. You've just defined an imaginary one. Right?
I'll explain to you how the border was decided. The border was decided.
No, we don't care.
I'll explain to you why we've decided on this 100 kilometers.
It doesn't matter how you.
No, I don't need to know that. No, I don't need to know it.
How we decided the 100 kilometers. Here we go.
No, that's okay.
So what we decided.
That's all right. I don't need to know that.
No.
No.
We do need to know that because this is how we decided.
It's arbitrary.
Here's the decision. Here's how we decided what constitutes.
We don't care how it was arbitrarily decided.
There is a diagram. We want a diagram.
Whether or not something has to be going on.
Make him do a diagram.
Something or not has to be going at orbital speed to stay up there, or whether or not it can go at a smaller speed. And 100 kilometers.
Don't believe you until you do the diagram.
It's not on another fictional construct.
Above 100 kilometers.
You still don't have a volume. You still don't have a volume. That doesn't mean that you've defined that's not a discrete. It's not a discrete volume. And hey, Rumpus, why can't the pressure be changing within the volume? Did you measure this pressure change at this arbitrary line up at the Kármán line?
Well, we know. Yeah, but there's a little bit. Well,
Rumpus, how did you measure, Rumpus? How did you measure the vacuum?
Which vacuum?
Well, let him answer Brandon's question. And that was a good question. Are you actually measuring this gas pressure? Let's see the measurements of the gas pressure at 60 miles or whatever.
That's why people send up balloons, meteorological balloons. They're always measuring the pressure of the atmosphere. We've got lots of diagrams, lots of data. Yes. We send up rockets. I mean, they send up rockets up there to find out what the pressure is at any one time. And the ISS, for instance, is constantly having problems. For instance, or Skylab, for instance, the reason that came down prematurely was because the Earth's atmosphere expanded, and that caused the drag on it to increase, and therefore it caused it to crash. They were hoping to keep it up there for longer, but the Earth's atmosphere expanded.
There was no dragons on it.
They didn't, and then it caused drag on it because it's still in low Earth orbit, and the atmosphere expanded a bit, caught Skylab, and so it caused extra drag, and so it fell down. So it's constantly expanding and contracting.
All right, we got it.
The words you hold on, Rumpus. The words you say. Hold on a second. Rumpus, the words you say is like something you would say to like a bedtime story to a crackhead or something.
With science, I know you appreciate.
If you were telling a bedtime story to a crackhead, you'd be the perfect person to sign up for that.
Science is magic because you don't understand it, and because you don't understand it, you reject it. We understand that.
Rumpus, in science, you need to show us some examples. If you go to the bottom of the ocean, you bring back a sample. Bring me a fucking sample of your vacuum probe.
We have done. We've been up there. Exactly what they do.
Where are they keeping this vacuum so I can see it?
Bring you a sample of
they take samples from rockets. They send up rockets. There's a special name for these rockets that go up into higher atmosphere just to grab Earth atmospheric samples. I can't remember. There's a special name for them. I can't remember what they are called now. Not star rockets. And anyway, they go and grab samples and they store them.
Sounding rockets.
NASA or something.
Sounding rockets is what I'm calling.
Yes, that's them. Thank you.
So there's a place on Earth that's storing.
That's the most intelligent thing you've ever said, Brian. Well done.
No, thank God we've got someone here to update Rumpus. Thank you, Brian.
Yeah.
You're telling me there's a place somewhere on Earth where they're storing space from space right now?
Yeah. Atmosphere.
Where's it at?
Do they hold this atmosphere inside a container?
Of course they do. Otherwise it'd disappear off, wouldn't it? Gas, remember,
you can't have gas pressure without a container.
Gas, remember, runs around at 500 meters per second at room temperature. So if you wish to not have it run off, you need to contain it. What's difficult to understand about that?
We know that's been our argument from day one. That is a good point, yes.
Yes, and what you need to understand that gravity acts like a container. Big bodies of mass exert this force called gravity, and that's what keeps the atmosphere in place. And we know there's no container because we've been up there and we know it doesn't exist, which invalidates the whole line of logic that you employed.
Wait, if there's no container, then how do you have any kind of upper atmospheric atmosphere?
Because of gravity.
You told me that you need a container to bring it down to sea level, but then that there's no container overall. So there's just
correct.
What's
gravity's a big vacuum.
Okay.
I'll explain for the 10th time. Gravity is the container for the atmosphere. Hold on. I'm in the middle of a sentence.
Listen to me. Listen to me. You have to listen to me. I'm talking to you.
You can have a turn next. I was in mid-sentence. You interrupted me. Gravity is the container, and that accounts for the density gradient. Go ahead, idiot.
What I'm starting.
Okay. No. It's my time. It's my time. I will talk with.
You're incredibly rude. You are incredibly rude.
Yes, I am.
Yeah, you are. I'm glad you admit it.
I admit it. Yes.
Okay. One thing.
Sorry. Don't talk over me.
You're drunk, can't you again?
No. I will ask Rufus one question. He has to answer these questions.
All right, let Johnny get his question out, and then we'll go to you. I can't see your name on here with the Mayan symbol.
Thank you. Thank you. Wow.
I won't be long answering it. Don't worry.
Okay. Where is your fucking radius?
Where
you are? Yeah.
What's the radius of the Earth? I'm about to measure it.
Of your globe model.
I'm about to measure it in a week or so's time, and then I'll be able to show it to you.
Oh, really? You can't. You know you can't, and you know
you're able to. I'll be pointing at it. I'll be pointing at the drop. I'll be showing you the Earth drop. I'll be saying, here, look at this point up here. This is horizontal, and here's where the Earth is. Look at the difference. That's the Earth curve. There you go. Finished.
That's what we expect on a flat plane, though, Rumpus. What are you talking about?
No. Nobody. I'm talking with Rumpus now. Nobody can interrupt.
Well, Brandon can. I mean, you don't.
It's
You're not the
Brandon's
moderator
channel, my
here.
man.
No, I will take you down. I say it, I will, and I will not. Anybody
Be careful,
can
Rumpus.
interrupt. I will ask you. How do you think you can rambling on?
Yeah, you are. You are rambling on. Yeah, you've yet to ask a question again. Yeah, you're going to get the question now or not?
Okay. How can you
my God.
explain for the people that is in the chat and everyone
Get
that
on
is
with the
listening?
question.
How can you prove the fucking radius of your globe model?
I just
in
said
real
I'm
life?
going to be showing it to you in a week or so's time. I'll be pointing at the drop.
Oh, you will do it later. Okay. You okay? You have no answer. Just now.
All right,
Just
hold,
like that
hold
time
on.
you
Let's-
show your
later,
model
okay?
of the horizon.
Thanks, Johnny.
Right.
Let's go to Carlos.
5 years
Carlos
later
was
now.
waiting.
Yeah, if Rumpus goes on and on about the fucking speed of gas molecules, I'm seriously doubting this calculation that he has for the speed of gas, because the only way that they can observe this is if the gas is in a container to measure it.
It's irrelevant how you measure it. We just measure it and we know what speed is.
Yeah, but you're measuring it in a container, you dips.
Doesn't matter where it is when you measure it. It's still doing that velocity, you idiot.
If I opened up a fucking can of gas and it just went into the atmosphere, how are you going to measure it?
Because we know, but from
You know
we've, right, no, here we are. There are experiments.
Because
what they
we
do,
know.
I'll explain it to you. I'll explain to you what the experiment they do to measure the speed of gas molecules. What they do is they have a gas at one end of and a vacuum at the other, and then they have a rotating spiral-shaped thing. And then, let me finish. And then they rotate the spirally thing, and then only when that matches the velocity of the gas will it get from one end to the other. Otherwise, it will be deflected. So from that, they can find out the velocity of the gas, and then they can show that it matches
He
the
means
theory
to
that we have
say.
for it as well.
He means to say we can't.
Yeah, we can. I just told you we can. Yeah, I can
No,
show you.
no.
It's observed.
No.
You're a
No,
scientist.
is a swirly
how does
thing?
that-
Listen, wait. Is a swirly thing? Is that scientific?
Yeah, that's very
terminology.
Yeah, but for Travis, for an
Swirly
idiot
thing.
like you, I have to use baby language because you're a moron and don't understand science. You don't understand scientific terms. So unfortunately, I have to do it in a sort of childlike language in the hope that you vaguely understand what I'm saying.
If I
Can I
opened
Google
a
it? I don't even know
helium
what it
right
is.
now on the ground, you wouldn't know where the fuck that helium went to.
Can I Google the swirly thing, Rumpus?
Yep, you can.
It's on my screen
can we-
if you're
So, for
curious
instance, we
about
can
what it
determine-
is.
Swirly gas measure
We can
thingy.
determine that helium, for instance, you mentioned, moves much more quickly than, say, oxygen. I think the fact is a factor of 4 in there. So we know that helium atoms move much more quickly than oxygen. In fact, we know that it's inversely proportional to the square root of the mass of the molecule. And therefore, hydrogen moves the fastest, then helium, and then the next gas, I can't remember what it would be,
It's okay.
oxygen. So we know, and what's more, these measurements that we can make using this swirly thing, it matches the theory exactly.
It's called a helical groove drum, by the way, you retard. Jeez. Hey, but I did have a question. How does that equate? How do you just apply that? This is kind of a special circumstance. You've created this thing to measure the speed. How do you know that the air molecules just out in the wild?
I know.
Hold on,
I said, I'm
C4. Sorry.
I know I wrote you.
What the fuck?
Well, because they behave in the same, because we grab some in the wild and put them, and then in this experiment, and then we test what they're doing. And
Well, you
know
said that
it's
the
all good.
gas molecules are bouncing off the Earth, and then they're going at 25,000 miles an hour up out towards the atmosphere, and some of them escape because they bounce off the other ones. How did you measure that speed? How do you know it's not just, because you're using this fucking thing here?
Well, we also know that it's temperature related. We know that for instance, helium, using this spirally grooved helical thingy,
That's
we know
not in your model, Bones. There is no temperature in your model.
Can I finish, Mark? Can you stop interrupting me 4 words into an answer, you rude git? Can you stop being such a rude ill mannered git while I was in the middle of answering Brandon's question? You're rude. You're a rude git. You really are. You just love to systematically interrupt people, don't you? I was in the middle of answering Brandon's question.
All right, let's not go back to that argument. Go ahead, Rumpus. Answer my question.
You can have a turn in a second. But I was just in the middle of answering Brandon. You can have a go next. So, we know from this helical groove experiment that the velocity of things like helium or any other gas we choose is actually just dependent on the temperature, and so therefore we know from that it's the temperature that determines. In fact, there's a direct relationship between temperature and the velocity and the mass of the molecule. It's actually half mv squared is equal to a constant times temperature. And so from that, we know that the velocity of a molecule is dependent A, on its molecular mass, and B, on the temperature. It's only dependent on those two factors. Go ahead.
So, Rumpus, does this all happen within a container?
Well, the experiment's got a container, otherwise these molecules will disappear. Yeah, it's irrelevant. Just because there's an experiment that uses a container, it doesn't mean to say the atmosphere has one. Because you see, these experiments don't have a little black hole in them because they don't have sufficient gravity. Whereas the Earth is a great massive thing and does have a great lump of gravity. Just because we can model contain gases by using a container, the Earth can contain things using gravity.
Excuse me. You claimed earlier that PV equals nRT only applies to a situation where gas is under pressure within solid containment. You said it doesn't apply to your model.
No, you said that, Rumpus. I was here.
No, I never mentioned
said
solid
that.
container.
You said you can take that T out and replace it with a T.
I've never passed my lips.
Yes, you did. You're trying to use a solid container with gas.
I said fixed
Rewind it.
Right? And you're trying to use that as your backing, which is a real world thing. You're trying to use that as support for your claim and to answer a question that you didn't answer.
What question?
You were asked a question a few minutes ago and you didn't answer the question. You went into talk, and the question involved the container. And you
Which question? What question didn't I answer?
I can't remember the exact question, but it was asked for one of the Australian lads there.
I always make a point of answering the question. I don't dodge questions. I always answer them every single time.
Can we go back? Can we go back to the?
Yeah, Rumpus, my question was, how do you measure gas pressure without a fucking container?
Exactly, and he brought a container into it.
Well,
that's exactly it. A container.
If the gas is not in a container, then it's subject to atmospheric pressure. So therefore, it becomes part of the atmosphere. Part of atmospheric pressure.
Earlier, Rumpus claimed that PV equals nRT, but only plays a part where gas is under pressure within a solid container. Right? He claimed that within his model there was no solid container.
Basically, when you control
now you're trying to bring
PV's nRT does allow you to change the volume. So if you have a container that can change its volume, for instance, if you have an experiment,
you're trying to bring in real world things that happen within solid containers into your claim and to support your claim.
I never mentioned solid
containers. There is
containers.
no solid container. PV equals nRT does not apply to that. PV nRT does apply to the example you're giving. So it has nothing to do with your model.
Oh dear. Right. PV is equal to an RT. You are allowed to change the volume. So for instance, the classic situation is if you have a syringe, for instance. Imagine if you have a syringe. Can you stop interrupting my answer? Can you stop interrupting my answer, please? Right. So
can we not go? I don't want to rehash this whole argument you guys had for 20 minutes, but go ahead.
Well, I never got around to explain when you do apply PV 0 I thought it might be useful to actually tell you when you use PV 0 T. The classic situation is when you have a syringe, so like a normal syringe, and then it can change its volume, but you can then identify clearly what the volume is. So if you heat it up, you can see the syringe expand, and that is proportional to PV 0 T. You can change the pressure. You can apply pressure to the syringe, and then it'll reduce to that. So you've got the variables you can play with are pressure and temperature, and the volume will respond to that. So the volume is allowed to change, but then you've got to have a well-defined volume. In the atmosphere, there's no well-defined sort of expand and go smaller, and because there's no pressure exerted by space, then it's only gravity that's doing it. It's a much more complicated situation than inside a little syringe. Go ahead.
Okay, a syringe is a completely false equivalency because it is a solid, but it's not fully containing anything. And it contains liquid, not gas. So that's completely out the window, has nothing to do with anything.
God, you
right?
don't have syringe, but you've never seen a gas syringe. You've never seen a gas syringe, you moron. You start denying ignorant moron if you think syringes are not used to contain gas. You stupid, ignorant moron. You conceited twat. You think you know something about this and you know nothing.
Excuse me,
I am speaking. Writ large.
Excuse me, I am speaking. Earlier on, right?
Remember that, everybody. He said syringes cannot be used on gas. Remember that, everybody.
Plays no part in your model. So you cannot use any example of anything that involves any gas pressure under solid containment.
No, not at all. Where did I say gas pressure? The form of gas pressure, and people do not. You can still have gas pressure, but it doesn't. You moron. PV, by saying PV is equality does not mean to say that pressure doesn't play a role, you twat. PV is equal to NRT is only applicable in cases like syringes, but that doesn't. I never said that pressure doesn't play a part in atmosphere. You utter moron. You've just ascribed to me something I've never man. You strawman me like crazy there and ascribed to me something I've never said.
All right.
Pressure does play a role.
I have no idea what he was saying.
You're too triggered,
referencing
Rumpus.
him in the whole
He's
time.
too triggered. He's too triggered. All right.
Finish, Brandon. Can I finish, Brandon?
Yeah, Rumpus
Hello?
is muted now, but go ahead.
Thank you. Rumpus can't use any example where gas is under solid containment. Regardless of what it is, he can't use that to support his claim because he claimed earlier on that PV equals NRT only applies to gas under solid containment. It doesn't apply to his model where there is no solid containment. His claim is that gas is under pressure due to gravity, right? A force of gravity at that, right? And he claimed that there is no containment for the gas pressure, the temperature, or the vacuum. This was his claim. So he can't use examples. He can't use examples that involve PV equals NRT, which is gas under solid containment, and then use them to support his claim, which is completely the opposite.
I've got a really fucking good example. Okay, this is a question for Rumpus. Does gas have a smell? There's question number one.
He's deafened himself. He can't hear you.
If I let off a big fucking fart in the room and I can still smell it fucking half a minute after, does that mean that the gas is moving at a really slow speed? Because I can still fucking smell it, bro.
Wait a minute. Do farts move at 25,000 miles an hour?
You see?
Until they run into the first molecule that destructs them.
Or you like
I'm not
you could say this
about 500 meters per second.
Also to the globalists, they would have to say you've lost weight if you fart. There would be a measurable reduction. No, you don't.
Actually do.
You actually
You
don't.
lose like
read
half
it.
a
Look
gram
into
or
it.
something for a good part.
Yeah, read into it. You don't lose weight after a fart.
Okay, you're a moron.
Yeah, there's actually citation for this.
So if I put I take the equivalent size of a fart, which is let's say 10 cc's, and I put that on a scale in a container, I can weigh it. So I take that 10 cc's back out, it'll weigh less. They have weight.
Yeah, let's stick to the speed of gas, man.
The speed of the molecules. What happens to molecules when they bump into other molecules?
Bounce.
Right.
Apparently, there's a lot of women who have asked if you lose weight when you fart.
They would move at that speed if there was a vacuum. They would.
Technically, you would actually weigh more if you really wanted to do it, because once that gas is out of you, then you don't have any upward vector happening inside of you to the same degree. So you'll have more downward vector.
Yeah, that's right. I think Brian's right. Here's an answer from somebody online. You gain weight where weight is defined as a vertical force exerted by mass as a result of gravity after a fart. Methane is lighter than air. So when you fart, you release methane and hence lose buoyancy. The result is that on a scale, you would appear to get heavier. This is
Now,
kind of the
Moyak
same
has to deny.
situation that we were discussing last week with the container putting helium in it.
Yeah,
So
Moyak
W
has to
equals
deny the
mg. Hold on
science.
a second. Hold on a second, Chris. So you're saying W equals mg is wrong because we're getting rid of mass, but gaining more weight.
Yeah, this is where Moyak has to deny the science. Otherwise, he's debunked again. Day in, day out, he's constantly debunked, but he'll just double down. Anyway,
Okay,
even after
Crit,
citation.
you're a genius for it, Crit. That's all.
Yeah, it's a headshot when you shot yourself. It's like, just say something. Boom, debunked. It's that easy.
Hey, I don't know if you guys have you guys been given an answer on considering they claim that gravity is holding the atmosphere to the surface of the Earth. Therefore, the Earth is rotating, so therefore the Earth is rotating at 1,030 miles at the equator. That gas would be rotating at that velocity or spin, but then the upper atmosphere is actually rotating due to the jet stream at 250 miles an hour. So how do you explain, because if you were to have anything closer to the surface attached to it, it would spin faster at the surface than it would in the outer area, right? So what answer was given for that?
Nothing satisfactory.
Just to vindicate Moyak, methane is less dense than air, so I don't know why someone.
Yeah, it's not under pressure. It's under pressure, bitch.
But that doesn't matter when it's in your body.
Sure it does. If it's under pressure, it's gonna when you fart, it's gonna have less volume, so it's actually.
No, that's what I'm saying. That's what I'm saying. It's less dense than air, but it's in your body, so it's gonna add weight to your body for it.
So there's no volume in W equals mg.
There's
no V. There's no V in W equals mg.
Yes, but you're forgetting
They always
buoyancy.
try bringing volume up when it comes to W equals mg. There's no V.
You're doing a different calculation.
Bro, there's no V in this formula.
Right, but you're adding that in by adding density or buoyancy in. V is part of buoyancy.
Jeremy, you're exactly right. There is no V. There's only M and G, and you're adding M. The weight goes up. You debunked yourself.
No, we said when you fart, it makes you weigh more.
Yeah. Well, I'm telling you, if you have a fart in your body, you weigh more. When you fart, you weigh less.
So we move. You're saying we weigh more or less when we fart?
After you lose that gas, you weigh less.
No, that's incorrect. It's already been shown by Brandon that you weigh more.
Yeah, look at my screen, man. Rob Mundo. Rob Mundo said it. So.
Because of buoyancy.
Buoyancy
I'll look
isn't
for-
really part of weight.
Even though I trust Rob Mundo, I'll look for a different source. How about Quora? That's a shitty source.
Anyways, even with my example of when you add the mass to it, you can have a balloon sitting on a scale and then you add mass to it and all of a sudden it has no weight because it's not even on the scale anymore. You can say whatever reason you want.
That's a retarded way to measure its weight, dude.
You can say, well, weight is the measurement of the downward force.
No, it's not. Weight is not a measurement of downward force. Weight is mass times the downward acceleration. Whenever you're doing a what do you call it, a free body diagram, you would add all these forces in there. There'd be a downward weight and there'd be some upward buoyancy, but one doesn't negate the other. It's just if you're
upward buoyancy part of when I stand on the scales, then is upward buoyancy part of that. When I stand on the scale,
the scale's going to read the buoyancy and the weight.
Because of the air that surrounds me. Is that correct?
Yeah, it's going to read the buoyancy and the weight.
Yeah. So when I stand on the scales, if I'm in a vacuum, I'll weigh more because there's no air around me. Yes.
But no, your weight is the same. Your weight is the same. The scale is going to read your weight is the same. The scale is going to. Yeah, I know. Your weight is the same. The scale is going to read more weight though because it's.
Now it sounds like you're defining weight the same way you define mass. Strange.
No.
Yeah,
no. If you look at you have to look at the free body diagram of any of these events. There's going to be a downward force that whether you put it in water, in air, or in a vacuum. and there's going to be an upward buoyancy that you're gonna if you're gonna look at the what do you call that, the net weight, then you would subtract one from the other. But when you're just looking at the weight alone, the weight's consistent regardless of the medium.
So, Kosho, is my weight determined on the scales by how much downward vector my body has?
Yeah, the scale's going to be reading all the forces in both directions.
Yes or no? No, scales only
That's the
read
answer to your
one
question,
thing.
man. The scale's going to read both the forces in both directions.
Scales reads one thing, and that's a downward force. All right, that is correct, isn't it?
Yeah, the scale's going to be reading both the forces in both directions.
Okay, that's fine.
So if you don't account for the upward force, you're making an incorrect measurement.
That's correct.
So, do we have to account for? Oh, sorry. Ask it again, Brian.
Brandon, the reason I'm asking this question is that they're claiming that gas has weight. Yes, in a vacuum, I weigh more because there is no gas around me lifting me up. Right? Weight is defined as a downward vector. Right? Gas can't have weight because you can't weigh air within air for a start because weight is defined as within the medium. So you have your own weight is within air or within water or whatever. You have different weights depending on the medium. But
oh my goodness,
weight
rudimentary.
Weight on a scale is a downward vector, right? I weigh more in a vacuum than I do in air. Why is that? Because the air is actually lifting me up, right, a little bit. So that means that the claim that gas has weight is completely debunked. It can't have weight if I can weigh more in the vacuum. Because how can I be lifting up the weight, taking less pressure off the scale, putting less pressure on the scales in air than I am in a vacuum? How can I do that? Because of the gas. Gas doesn't have a linear vector. It doesn't have a weight.
There's interesting things you can do there. You can have a closed system, and then you can compress the gas and add your body and add the weight, and then you'll have a little extra pressure from the air. I mean, there's little weird things.
Very nice, Tom. Very nice.
All this shit's rudimentary. It's like get to the meat, man. Why does it matter? Why do you act like you're gonna just say there can't be a fucking globe when they have the fucking gravity all day? They act like it's strong enough. If you ain't talking about how the numbers of it ain't even strong enough, what's even the point?
Well, if the only gravity that causes weight is the force of gravity, and that was thrown out by mainstream science in 1915. When Albert Einstein's theory of general relativity was accepted, there was no force of gravity anymore. There was no more gravity causing weight.
Yeah, did you see what Einstein said about Did you see Einstein's equivalence principle?
How does that cause weight? How does that?
It doesn't cause weight. The equivalence principle is describing how weight. I'm sorry, not how weight. How gravity, being a force, is indistinguishable.
No, it doesn't. Gravity is not a force.
It doesn't matter, dude. It doesn't matter what you know, dude. Because you quote Einstein, you're forgetting what Einstein also said about it.
Tell us, right? Can you support where Einstein claimed that gravity was a force? Then, within his theory of general relativity.
Oh, that's not what I just said, is it? I said that the equivalence principle states that.
You say
the equivalence principle states. The equivalence principle states that it being a force is indistinguishable from the reference frame, causing acceleration.
What force?
These two things are indistinguishable as far as tests go.
Okay, what force was he? So you're claiming he used the word force. What force was he referring to?
Gravitational force.
The force of the realm.
A force of gravity. So you're claiming that Einstein claimed that there is a force of gravity which is mass attracting mass. That's what you're claiming.
If you're not going to listen to me, I'm not going to persist.
I did listen, and I heard what you said. Right. So you're claiming that Einstein claimed that mass attracts mass. So can you show me within his thinking?
Yeah, well, I'm just going to link the equivalence principle, and you can read it, but you probably won't. Anybody else can read it.
I don't need to read
any of the words you said. So
I don't need to read about it. You're making the claim that Einstein is claiming that there is a force of a gravity that is causing mass to attract mass that is giving us a linear downward.
If anybody heard me say that, then that's cool. You're stupid. But I didn't say that, so I'm just going to post the equivalence principle, and you can read it.
What did he claim? Because I was asking you. You claimed that when I said that Einstein, after Einstein's theory of general relativity was accepted, that there was no more force of gravity causing weight, and you said that wasn't correct, and you brought up Einstein's equivalence principle, and you said gravitational force. So, how in Einstein's theory of general relativity, right, within that description of what supposedly gravity is, how does this effect of gravity, right, cause me to have weight?
Don't they essentially say that, well, yeah, mass doesn't attract mass, but now it bends space-time. And the more the mass, the more it bends space-time, which causes other objects to go towards it depending on how much they're bending space-time. So they like changed it from a force, but didn't change it from a force, right?
No, that's not correct. There is no two masses. There's only one mass. He never accounts for more than one mass. Einstein never accounted for more than one mass.
Okay.
So there is no mass attacking mass. So weight, that your weight and my weight, whatever, that's just down to density of matter. It has nothing to do with a force of gravity or an attraction between two masses. Anyone who's claiming that is talking, either they don't know what they're talking about or they're lying. I know Rumpus is lying about that because I already had it out with him privately through Skype, and I nailed him on it. I destroyed him through Skype. But he's still, right, so he's just lying. Rumpus is just lying. Kosho, I don't know, maybe he's just lying as well.
I don't know, but it's pretty interesting. But anyway. So yeah, so this I did find a better source. This is Amy Chai. She's a MD of internal medicine. She's got a master in science. She said farting makes you gain weight, but the amount is negligible. How about that?
They'll have to deny it now because their framework was built.
Hold on, correct, Brandon. I sent you a citation. I don't know. They deny like what weight is. You know, in their crazy world of the gravity and all that. So, I mean, the first sentence of the citation, I don't know why Kosho was arguing with it. These guys are like denying what weight is because the W equals mg thing is totally bunk. That's why they have to deny what weight is.
Jeremy, define what you're saying when you say what we're denying what weight is.
Well, would you agree that weight is a measure? Would you agree that weight is a measurement of the downward force?
See, what you just stated right now was we were denying what weight was because we're denying. No, hold on, dude. Because you're lying right now. Are you being dishonest? You're saying that we're denying the W equals mg, and then you ask me a different question.
Measurement.
Because I'm telling you that W equals mg. That's what I'm saying weight is.
Let's define what W is.
If you ask the vague question you just asked, I'm going to say no to. I'm going to go back to W equals mg.
Okay, is weight a measurement of the downward force?
I just said I'm not going to say yes to that.
Okay, well,
because
here's a citation.
A measurement of the downward force. Yeah, I know. A measurement of the downward force is not only weight. A measurement is going to include any other forces in those two vectors, up or down. So if there's weight going on, there's magnetism going on, there's buoyancy going on, all these things would be included in that measurement. And that would be wrong to call that just weight.
But that is what we call the downward force of objects. We call it weight. When we measure weight, we use a scale or something that measures the force that it pulls downwards, right?
Yeah, but if you put a magnet on a freaking magnet plate or something like that, and the force pulling it down, you wouldn't call that the weight. And that's exactly my point. There's other forces present. You could call it weight colloquially, but you'll be wrong a lot. Sometimes if that's not the only thing, and it's causing a considerable amount of force downward. So, whenever you weigh yourself on a scale, there's a downward weight and there's an upward buoyancy, and you ignore the upward buoyancy because it's negligible. And there's also the centrifugal forces. There's other things that aren't being accounted for when we call that weight, net weight.
Yeah, but what you just did there, you just claimed that gas has no weight. because weight is a downward vector. Yeah, you did.
I did not claim gas has no weight.
I'll ask you a question again. When
I did not claim gas has no weight.
What does that measure? Does that scales measure my linear?
I just said exactly what I just said explicitly what it measures. I just explicitly said that it's going to measure any forces. It's going to measure any forces in either of those vectors, the upward vector or downward vector.
Do I have to go and get a reference?
I just stated that.
Do I have to get a reference, Kosho? Do I? Do I have to get a reference?
I mean, if you have to argue that, then that's absurd. That's absurd to even be arguing. It's an obvious point. It's an obvious point that a scale is going to measure any force that's going in either of those two vectors.
No,
that's obvious.
A scales measures.
Yes.
So when I stand on a scales, right, is that spring measuring my linear downward force due to my weight, or is it weight measuring buoyancy and magnetism?
If there's magnetism present and you're a magnet, then there's an atmosphere, then it would be weight. Then it'd be measuring all three. Yes. And what you would call that, if you want to be correct, is you call it your net weight. But in reality, you're weighing the scale is measuring multiple things at once.
So a spring is measuring several different forces at once. It's not just measuring how much.
It's downward pressure because you negate it with the tear button. Come on, this is easy stuff.
No, it measured the sum of all forces.
It doesn't. It measures one thing.
The sum of all forces.
Do we have to get a reference
It's
to
a
show
pressure.
me?
That's all it is.
Yeah, exactly, Lynn.
Brian is exactly right. It is just one
What?
pressure, one vector.
He
That's
was
all
never
you
right
need.
in his life.
I mean, this is almost common sense, and it's almost ridiculous. If you have a scale right above a magnet, and you put a magnet on that scale, if you think that what you're measuring is the weight of that magnet, you'd be a retard because you know there's a magnet underneath it pulling it down. And so what that tells you is just like Chaiki just said, what you're measuring is the addition of all the forces added together. The net result of that is going to give you whatever you measure on the scale.
Yes, but we don't say we're 12 stone or whatever pounds in standard air pressure, do we? We just take it as a norm.
No, because
That's
for
what
us it means nothing.
That's what I just said. Yeah, exactly. I just stated that colloquially you call that weight, but if you're being technical, it's not. You're not only measuring your weight in that instance. You're measuring, at least two things.
Does the scales have a magnet in it?
You could say you're weighing the influence of the rest of the universe. So what?
It means fuck all. It doesn't change anything. No, not with the scales we use.
Exactly. Brian is exactly right then. So stop arguing.
No, but when you measure air, it does.
Just only measures one thing. That's the whole point of it. How much
When you
downward
measure
force
air, it does.
apply to it.
Yeah.
That's all it's
Claim
been.
there's these other forces.
A bit more careful when you measure air.
Yeah, I got a scenario for you guys. Let's say I have a tank, right? Like this. And I've got a scale right on the bottom, right? Of the tank. Can you guys see my screen?
Yep.
And then I put like a sloped object like this right on the bottom. And I'm measuring the downward force of that object in this tank from, I guess, underneath. I'm measuring the downward force of it, okay? And then I fill this tank up. Right now it's just got air in it. I fill this tank up with water. This object here, this triangle, is supposed to be more buoyant in that water, right? So it should weigh less, correct?
I can't see your picture because I'm driving, but just let me know, is the scale inside the tank or outside the tank?
The scale is like the bottom part of the tank.
Okay, inside the tank, okay.
Where's the
And you put
triangle
what in there?
inside the tank?
Yeah, there's a triangle inside the tank, like a pyramid, that the scale is measuring the weight of that pyramid. Right?
Okay.
And then
there's air in there as well?
There's air in there. Okay. And then I'm going to take the measure of the weight the downward force of the red object, and then I'm going to add water to the tank. Is it going to weigh more or less, the red thing?
See?
I got shit.
Because you guys talk about it like there's the buoyant force is some kind of upward force. I'm just curious.
It depends on your mechanism.
Okay, tell me about that. What do you mean?
Okay. If you are dangling it from ropes using a scale, traditional scale, then no, it will weigh the same. However, if you're talking applying a pressure force on a pad, then yes, there will be a difference in, because it will float up, slowly float up through the buoyant force acting on. Yes.
This thing's heavier than water, though. It's more dense than water.
But still, it will still have an effect.
Okay, so this will weigh less. Now, I'm told that this is because buoyancy puts an upward force on the object. It pushes, it's often described as pushing the object up. But how the fuck is that possible? If this is flush with the bottom and its sides are sloped like that, and I've put increased water on it, put more substance on top of it, how the fuck can this thing suddenly weigh less being pushed up? There's nothing pushing it up.
It will be. You'd have to have a perfect, if it was perfectly wrung to it, then there would be no water or any material that could get in underneath it,
Right.
break it, and yes, you are correct. You are.
So it wouldn't weigh less then. If it was completely flush to the ground, no water could get underneath it, it would still weigh the same.
Yeah.
And the water's not the water isn't impacting the scale at all, right? It's just measuring the downward force of the object.
Obviously, obviously, I was assuming that you'd weighed the water, and then what you're doing is putting the water in there, and then negating the weight of the water, leaving the weight of the triangle. Yeah. Because obviously, if you put that water in there now, it's going to weigh lots more than the one on the left.
Yeah.
Yeah. So, but exactly what you just said, though, is correct. Yeah. The pressure of the water will push it down, and if it's wrung and there is no way that any other pressure force can come in and counter that, then yes, you have got full contact and you are going to weigh the full object. However, if there is an opposing force, it will not seat on the actual scale fully, and it will not pull down. However, if you hung it, there's obviously if it's freely suspended in air, there's no difference in the total weight of the whole thing, basically.
So this one will put as much downward pressure as this one, if it's totally seated on the bottom, and no water can get underneath it.
Yep, that's it. If you've got no opposing forces and everything's coming down on it, it should weigh the same.
Okay. Thank you.
Yeah,
That helps clarify the model for me a little.
Yeah, it's only buoyant when there is opposing force going up. That is buoyant.
Yeah, that's the part that always bothers me is we can't measure this force. We only measure this one force, which is going downwards. This pushing force from underneath. No one has been able to describe how you would measure that. Like if I just had this in here and I wanted to measure that pushing force upwards.
Well, it's more its own mass resistance against an object. So if you had that same thing on the top of a skyscraper, and then all of a sudden you remove the skyscraper, you're removing the 9.8 meters per second that skyscraper was pushing up on that object. and therefore that object is now free to fall. If that makes sense, it's kind of like the opposite to a force pushing down, which is exactly what Einstein said. And to say earlier, Brian was exactly right with that as well, because Einstein literally went to the Royal Society saying Newton was wrong, and he got literally laughed out of the Royal Society, saying, "Shut up! What are you talking about? This fourth dimension space-time? It's absolute stupidness. Go away." And he got laughed out, and that's why Arthur Eddington took pity on him as a case study. And they decided that Mercury was the going to be the proof. Represented it back in 1905, and then bang! As long as they had evidence, no one could laugh. Put it that way. So he did overtake Newton. Definitely, he called Newton wrong. It's a wrong way of thinking about it. Gravity is not a absolute frame of reference force.
On their claims of buoyancy, like how a helium balloon goes up within the claim of buoyancy. And buoyancy, by the way, for anyone that doesn't know, because there may be people there that don't know, buoyancy is only connected to a force of gravity. Buoyancy also went out, and the theory of buoyancy also went out. Well, it didn't go out because it was around before, because basically Archimedes' principle is buoyancy. But it was around before. Yeah, exactly. Yeah. It was around before the theory of a force of gravity turned up. But buoyancy, like for a helium balloon going up, that means there has to be air coming down. So air is coming down, forcing the helium balloon to go up. Now, that may not be totally incorrect, because you do have more dense air coming down with convection flowing down the way, but you also have warmer air flowing up the way, which would also help lift the balloon. Because you have to remember, the balloon material itself is more dense than the air. It's only the concentrated helium within the balloon, and obviously convection, that helps the balloon to rise. And I would say in a warmer climate, helium balloons, like at the equator, will probably rise a bit faster because there's more upward moving convective air. Because there's more convection going on around the equator, because it gets more direct sun. But they are basically, buoyancy is a replacement. It's basically a density replacement, which is, buoyancy, when they speak about it within their model, it's a density replacement. But that density replacement requires temperature. But as Rumpus stated earlier, and I'm not going to stick this to every one of the ballers, but as Rumpus stated earlier, temperature is part of PV equals nRT. He said that doesn't apply when within his claim of gas pressure without a container. He said it doesn't apply there. Because in their model, right, the gas pressure gradient is caused and created only by a force of gravity, right? Well, that's within what.
Don't drop those keys. Leave it open. Leave it open.
And whereas temperature, we can show all day, every day, how temperature, and official documentation speaks about how temperature creates the gradient. So, but I mean, you will find claims of gravity being involved, but what can you do? But the problem is with PV equals nRT, the T basically for the force of gravity claim, the T has to be taken out and replaced by the G, and it has to be an open system and not a closed one. So that's what they have. PV equals N or G, and V it's variable. It doesn't mean volume, because they don't have a volume. Because volume is a fixed.
PV nRT though,
like 1 liter or whatever.
I thought we all agreed that that was subject to being a variable.
Well, no, I didn't
variable
agree.
based on temperature.
No, I didn't agree. No, volume. A volume is a fixed amount. Volume is a fixed amount. Like.
No, actually, what's the volume of a half full garbage bag? Well, if I was to take a half full garbage bag and put air in it, and I was to warm it up 10 degrees, how much would that increase the pressure? None.
Yeah, but you have to contain it.
Is the volume
within your model, there is no containment. This is the problem. So you can't.
No, there is containment in our model.
The only reason you can define the volume then is because you have a contained volume. Well, you can take a balloon and fill it with air and heat it or cool it, and it will change the volume, right, of that that balloon. But you can only state a volume because you have a containment. Without a containment,
I can heat up the air like in the atmosphere, and because of the resistance of other air, I can raise the pressure. In other words, I can take an explosive, detonate it. That's going to raise up pressure, but because the volume is increasing slower than it needs to, the pressure will increase.
Yeah, but you can't state a volume without a container, right? Even if your volume is going to vary,
the volume
like a
of that
balloon
explosion is. I have X number of molecules heated to 10,000 degrees. I have X amount of molecules heated to 10,000 degrees. They're going to expand at such a rate. That'll give me a pressure.
What has explosions got to do with a volume?
That's the volume varies. The pressure is going up against other atmosphere, and the resistance to the other atmosphere is where you get the pressure, I guess. Plus, just the closest.
No, but you don't have a volume. You don't have a volume. You
not a fixed volume.
A volume is a calculated amount. Do you understand?
It's not. It can be variable. There's no reason it can't be variable.
Yeah, but you can vary a volume, like you can heat a balloon full of air and make it expand, or cool it and make it contract. Right? You're changing the volume, but you can't measure that volume. You can't call something a volume if it doesn't have containment. It has to have containment.
I can just call the volume X.
Sorry?
I can just call the volume X. It's a variable.
Well,
it changes.
The whole point of the word volume is it's an amount, a specific amount.
Not a specific amount. It can be variable.
No, a volume is a specific amount. You can vary a volume, right, if it's contained, because you can then call, once you heat the balloon, you can say now the volume of it is this, right? You can cool the balloon and say the volume of the balloon is this, but you can't state a volume unless you have a container. You can't state a volume.
No, that's not false. That's totally false.
No, it's not totally false.
Volume can mean
one cubic centimeter of air in front of my nose. There's no container, but there's still a cc of air in front of my nose. There's lots of them.
Well, in your claim, there's no container, but I wouldn't claim that, obviously.
Well, because you might not say it, but I can, without a container, I can measure, or I can tell you that there's a cc of air in front of me.
Every time I go to speak, I seem to speak. Give me a second to speak. I have no evidence of gas pressure being created without solid containment. So you can make the claim that in front of your nose there's air and that's not contained. Grand. But I would claim that there has to be a solid container on the bigger scale. Because we have gas pressure, temperature, and a vacuum. And there's also a vacuum, a low-grade vacuum or pipe. That has to be contained. And that is created by temperature.
I can have high pressure next to a vacuum with an open container.
Can you show that demonstration then? Can you show high pressure? Sorry,
high pressure next to a vacuum.
Sorry? What
high
did you
pressure
say?
next to a vacuum in a centrifuge.
What's a centrifuge?
You take a little vial, you take an open vial, and you centrifuge is something that spins really. That's something that spins really fast. Centrifugal force. So all I do is I take a test tube and I go in the center of the centrifuge.
And what creates the vacuum?
Who gives a shit?
Well, it's important just within your claim, because you're claiming that there is high pressure that is not going to low pressure. So what is is this centrifuge a container by any chance?
It's irrelevant. You're saying I can't have high pressure next to a You're saying I can't. You're saying I can't have high pressure next to a vacuum. I have high pressure next to a vacuum in that situation.
So you're claiming that there's high pressure next, and what creates the vacuum? What is the creation of the vacuum in the center? You said it's in the center.
That was air pumped out, whatever.
Right, and air pumped out, and this is a contained system, yes?
Sure, but there's still a vacuum, and between the high pressure and the vacuum, there's no container.
Right, so there's high pressure. You're claiming high pressure that doesn't go into a vacuum, and it's within a container.
Yep. Doesn't really matter. So it's a vacuum next to a container, isn't it?
With a container.
Is there a vacuum next to a container? without a barrier.
I don't know. It's your claim.
I know, but I'm saying I'm describing the situation. I'm asking you: is that the definition of a vacuum next to a container?
No, it's not. It's not. It's not equivalent to your claim about us having.
My claim is that you can.
Because you have to have containment to create that situation. It's not possible
That's
to
irrelevant. It's irrelevant. There's still there's a open container next to a vacuum with high pressure.
It's extremely relevant.
And if
you can't create that situation
if I spin that at 500 meters per second, that container will have high pressure at the bottom of it.
Is the vacuum created due to the movement of the air?
Well, you could do that. I mean, you could probably make a centrifugal. In fact, just take the whole damn thing and make it into a centrifuge. If I just start spinning it, the air will start sticking to the sides and going out further and further, and a vacuum will form in the middle.
So let me ask you a question. So the vacuum forms due to the movement of the gases. Is that correct?
Due to a force.
What force?
Centrifugal. A pseudo force called centrifugal force.
The movement of the gases create a vacuum in the center, yes?
Yes.
In the centrifuge. Right. So
yes.
How is that equivalent to your claim that we don't have any containment for gases or any containment for a vacuum or temperature? When
it's
this
just proof that you can have vacuum next to a container with a force.
Yeah, but this all happens within
you have vacuum next to a
you
now
do
we have
realize,
a force. We have an asserted force.
Yes. So you're just creating a high pressure and low pressure system, yeah, within that solid containment.
So.
Yeah, so it's just a creation of a high pressure and low pressure situation within that solid containment, and it's a specific
still a vacuum
example that involves a container. Otherwise, you couldn't do it.
I thought it was a universal law that you can't have a vacuum next to a container, yet I can have that.
In your model, does the movement of the air create the vacuum of space?
No, gravity causes the
so
vacuum. In fact, vacuum is what gravity is actually what causes vacuum.
So your example is a completely false equivalency then.
There would be no vacuum in space. There are no discernible vacuum in space without gravity.
Right. So, but it's a completely false equivalency. Because you're showing a man-made, solid contained situation where a low pressure system is created in the center and a high pressure system is being created on the outside, right? But this has no relevance whatsoever to the claim that the globe Earth makes, because in your claim, right, the movement of air around your globe Earth does not create a vacuum outside of it.
Well, I think it's the reverse, though.
What's the natural law observed?
Can I say something here? I'm trying to think how that wouldn't be a vacuum next to a container if you did that. I mean, a vacuum next to air pressure if you did that. Does that work? Does that actually create a vacuum in the middle of if you did that?
If you spun it fast enough, I would say yeah.
So it doesn't create a vacuum. So is this your claim? Sorry, Brandon, for stepping in.
Well, I like the.
Well, I'm just trying to. We've got this premise here. We've got this premise here that we're saying that if you spun this centrifuge with gas in it, that it would create a vacuum in the center. That's what I'm questioning. Has this been done? Is this an actual experiment?
What do you call a vacuum? What do you call a vacuum?
Sorry,
well, let's say equivalent to this fucking space above the Kármán line. Let's go with that.
That would be, I guess, it would be a bit difficult to do.
Yeah, I mean, has it been done? Has this experiment been tried?
No, there's a limit how fast we can spin objects before they break down.
The materials.
So what are you saying? We'd have to spin it really, 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 really fast in order to get the vacuum in the middle?
To create space vacuum, yeah.
So is this a theoretical?
In excess of 500 meters per second.
Yeah, but to create a force of an atmosphere in the middle, I think that's possible.
Yeah, but is this then a theoretical claim, though? That's what I'd like to find out.
Not.
I know they make gas centrifuges. They do it a couple of ways by just like essentially spinning the air by using velocity to spin it. You know, like under pressure, you can separate gases that way. But I'm not sure, like a straight up centrifuge, I'd say anytime we'd have to look at the fastest centrifuges and find out whether they have vacuums in them. I don't have an example.
Yeah, I think that would be the, you know, kind of a necessary component to making that argument, Moya, because I do question, I can picture it. I mean, I can, if that's a thing, I think that would qualify with some caveats, but is that really possible? That's what I'm wondering.
Yeah, I'd have to look up the specifics of gas centrifuge. I just know that it, as you will get a pressure differential, definitely, especially with my scenario of the test tube in the centrifuge instead of spinning the whole unit, because you could introduce air to the bottom of the test tube, and it would not leave that test tube at somewhere around 500 meters per second.
Yeah, but I can create a pressure differential within a balloon filled with air. But that doesn't make it a vacuum. That doesn't make something a vacuum. A vacuum is an official term.
Really?
It has a particular
You can make a pressure differential in a balloon.
Amount of
that's semi-permanent
per cubic meter or whatever.
I mean, there is a pressure differential. There's a gradient inside a balloon, but
yeah, it's a pressure differential. Yeah, you just talked about a pressure differential.
Yeah.
You claim
there will be a gradient inside a balloon. At sea level, it'll be similar to that of air.
But hang on, yeah, but you're not listening to what I'm saying. You claimed that there was a vacuum being created, right, within this container by the centrifuge, and it's being created by gases being moved around it. And so those gases are high pressure, and there's a low pressure system being created in the center. But now that's become just a theoretical claim, from what I'm gathering. You don't even have that as a claim.
I don't have an example handy. I'm sure I can find one if I dig around enough for you.
Yeah, but
I'm looking it up right now. I mean, nothing's popping up. Do you have a name I could look up of this experiment?
Gas centrifuge?
Yeah, I'm looking at gas centrifuge. It just brings up some stuff about uranium enrichment.
Nuclear?
Yeah.
But it still doesn't matter because it's not equivalent to...
You'll have to go look at the specifications of it and see whether you actually get a vacuum, but that's what I was thinking of. That gas
but it doesn't matter.
Uranium.
If you look at the answer, somebody asked this question on Quora, and then the person who answers said, yes, this is basically what a centrifugal pump is. And you think about it, it is what it's doing. I mean, it's pumping the air by spinning like that, so that's exactly what it's doing.
Yeah, but what is the force that requires?
Centrifugal.
I mean, this gravity is not that strong of a force, right?
It doesn't have
You guys
to.
always talk about how weak a force it is. It's the weakest force and all that.
What it has to do is over thousands of miles, it has to be able to slow. It has to be able to slow something down. So over thousands of miles, the gravity affecting that molecule it's trying to escape Earth, it has to slow it down and return it back to the surface or to the atmosphere.
Why would it slow it down if it's moving away from the mass? Why would it continue to get slower?
The same reason a bullet comes back to your hand. It goes up really fast and it starts slowing down, and it comes back. And if you hit it again with the racket, it goes up again, which is kind of like what you see with the atmosphere. You keep hitting it with sun and cosmic rays and shit, and it keeps getting knocked off the atmosphere, and it goes out less than 20,000 miles an hour. And over the next few thousand miles, it keeps that constant drag on and pulls it back.
Yeah. Okay.
And then there's that point
most
when it
of
gets
the
over that speed. Go ahead.
No, I was just saying that because you have to remember the atmosphere down here, the pressure is from the weight of all the gases above it. The gases that Moyak is talking about is all the way already at the top, where there's not, doesn't have that pressure to get in the way either. So, it just has to be energetic enough to escape gravitational pull. So I wouldn't say gravity.
We talked about that. We talked about that.
It's not really weak.
We talked about that the other day when you made that claim that the column of atmosphere above you is actually pushing down on you. Right?
Mm-hmm. Yeah. The weight of the atmosphere.
Substantiate that in any way? That the column of the atmosphere above me is pushing down on me?
Well, first off, it's not pushing
Yeah, sure.
down
Yeah,
on
this
you.
is
It's
what
pushing all around
no,
you.
this is what that's what Torricelli proved, or basically demonstrated whenever he made his barometer. He demonstrated this to everybody who didn't believe that fact. That the air
The
actually has
barometer
weight
doesn't
and
show a
it's pushed down.
downward pressing force, though. It's just a pressure. It just
It does.
measures
That's-
pressure of the environment that it's in, right?
No,
Well, I think you would
that's why
need to
I tell you that the way
substantiate
that's
this. You're telling me that I weigh more because there's a column of air on top of me pushing me down.
No,
Right?
it's pushing you in
weigh
all
less.
directions.
Yeah, it's in
Is
all
it
it's in all
pushing you
directions.
In all directions, or it's a buoyant force?
Yeah,
Is
but
it
that's
producing
not
enough?
the weight. See, Kosho's,
I don't have any air underneath me pushing up.
Yes, you do. Just like a water pressure. See.
No. I'm standing on the ground. There is no column of air underneath me pushing me up.
No, it pushes on your legs.
No.
Up also.
It pushes
But
up because it's in the soil. It's under your feet. And if you're standing on a perfectly smooth surface, your feet aren't going to be perfectly sealed to that floor. And if they are, then you'll get kind of like a little bit of a vacuum effect, but it's not going to change the fact it's pushing on the rest of your body equally in all directions.
You know what? I got to tell you, I think that this model you guys have takes a lot of imagination in order to make it all work. And you guys add a lot of stuff to it that doesn't seem to necessarily need to be there.
No, but you can show. What Mark just said can be shown to you in water. Like if you have something like a boat or something, and it's completely flush with the smooth ground, you could place it down there in such a way that there would not be there wouldn't be anything to get in underneath the boat, and it wouldn't lift it up. But that would you'd have to get it perfectly flush with it. And there's there's engineering that does this.
We're talking about air though, not liquid.
Yeah, no, but it's the same thing. It's the same
Not
effect.
the same.
Buoyancy.
That's what your
Same
claim
as-
is, but you have to substantiate the claim that it's the same for gas. That's what we're talking about.
well, if you ever try
Brandon.
to separate two sheets of glasses, you see it's very hard to separate them because they're quite stuck to each other.
That's vacuum.
The air can
Brandon.
go in.
Yeah.
Brandon, earlier on, just quickly, I'm going to have to go. Earlier on, we established, and Kosho even admitted, that scales weighs a downward vector. That's what your weight is. That's what weight is defined as, a downward vector force, right?
That's not what I said at all. That's not what I said at all, man. So don't quote me, dude.
We
Like
also
if you're gonna
established-
just make up
we
stuff
also
that I didn't say.
We also established that when you fart, right, you actually gain weight, right? And if you stand in a vacuum, right, not that you can, but if you stood in a vacuum, you would weigh more than you do in air. So there is no weight of air, right? Because air is the medium we're weighing things in. So you can't weigh air in air, unless you put it into, or gases in air, unless you put them into a solid container. You can't weigh gas as gas. Gas doesn't have a linear downward vector, right? That's why when you fart, you gain weight.
No, you
Right?
don't.
So there is no,
You don't have
there is
a
no
beer
linear
belly. If you
downward
have muscles, you
as
don't.
weight is described. Weight is described as a linear downward vector. Gas doesn't have that. Gas presses in every possible direction at all times. So
yeah,
they're talking a lot of
if the atmosphere was pushing down on me, then if I was in a vacuum, I should weigh less, right? I don't know. Like I said, I understand why you guys wrote your model the way you did, and I'm sure the variables work out for the most part, but there's these concepts that I can't tie them quite to the empirical evidence we see in
Brandon,
reality.
hold on, whoever else was going to say something, because it's not the concepts aren't like Moyak said it before when he said the pressure is acting in all directions, and when you have a scale, the pressure is acting in all directions isn't going to add anything to a scale because its pressures are acting in all directions. So the pressure is not adding weight onto the scale.
It would be adding weight onto the scale. You've got a column of air above you pushing you down. Your claim is that there's also air on the sides of you that are pushing you up, I guess.
There's air all around it, man.
Or we could just say
There's
that
pressure in all directions.
Things have different weight in different mediums. Hey, I want to go back to something you said the other day, though. When you were telling me that I could weigh the water that an object displaced in order to figure out something. And I gave you an example of a lead ball and a titanium ball that are two different weights but the same size. They're two different densities but the same size. And they displace exactly the same amount of water. So how would that work?
They weigh less, they weigh different.
Yeah, so the force acting on these objects would be the downward force of their weight. So if you draw a picture, you have an arrow pointing downwards, and it's mass times acceleration, you get its weight. Then you have an upward force that would be equal to that volume of that volume of weight. So that weight of that volume of water acting upward on that same object. If it would, so both those objects would have different measurements, and it would be a product of those two things. The
Okay,
downward
so
weight
now
and
I
upward
understand.
points.
So what you're saying is that will be the same amount. It'll be the same amount of water, regardless of the ball. You'd subtract the weight of that water from the weight of the ball, and that would give you your weight of the ball within the water.
Yep.
Yeah, sure.
Well, is that it or not?
Oh yeah, no, that makes sense. I thought you were asking about weighing. I thought you were asking about weighing the buoyancy alone, but yeah, if you're talking about weighing the buoyancy and then using that to calculate what it would weigh in the water, yeah, you would do exactly that. You would subtract the buoyancy and you get the weight of what it would weigh in that medium.
Okay. All right. Well, it's about 8:06. Earth is Life did have a super chat, and it was directed at Brian. I know he said he had to leave. Brian, is the container holding our atmosphere solid? If so, what would we use to detect it and determine its distance?
I have no idea what the container is made of or anything else like that. I would say it has to be solid, solid, because you need a solid to contain a gas. So I have no idea, but I don't know I don't know what it's made of. That's all I can say.
Okay, fair enough. Thanks, Earth is Life. Hey, I want to make one more statement about this whole gas pressure and gravity thing. Personally, I don't think this has anything to do with the shape of the Earth, except tangentially. It has more to do with the heliocentric model's viability. These things can all be true, in my opinion. Everything we observe can work exactly the same on a flat Earth, just for different causes, which aren't really tied to it anyway, in my opinion. But anyway, interesting stuff. It always throws my head for a loop when we talk about buoyancy and fucking what'll add weight and what won't add weight. It doesn't completely add up for me, but maybe I just misunderstand it. Anyway, thanks to the panel. Appreciate you guys joining the show tonight. And have a good weekend. I will be recording after the show, just so you know, if you're in the room, that you're being recorded. It usually runs all night. If there was anybody who didn't get a chance to speak during the show, or has something they're dying to say to the YouTube audience before I kill the feed, now's the time.
I have something to say if no one else comes in.
Okay.
The reason I came in tonight, I'll make it sharp. The reason I came in tonight was I was listening to the debate earlier, and there was the talk about how the air basically moves in lockstep, will move in lockstep with a moving surface. Their claim of their atmosphere moving in lockstep with their globe out as it rotates, right, 15 degrees an hour. There is such a thing called friction boundary layers. To give an example of this, if you have a cup of coffee and you stir it, eventually that coffee will stop spinning, right? The coffee inside will eventually go still. It'll stop moving around. The reason is that the liquid creates what's called a friction boundary layer with the surface of the mug, right? So it starts to slow it down. Now, a superfluid, that doesn't happen with a superfluid, let's just say, but it will happen with most normal liquids, right? Or all normal liquids. It just doesn't happen with a superfluid. But gases, right, that happens because partly that happens because liquids are bonded, right? But gases are unbonded. Gases do not have a friction boundary layer with surfaces. So they need gases to have a friction boundary layer with the surface of Earth. And for that gas that is being creating a friction boundary layer with the surface is also connected to all the other gas molecules, and they're all pulled around together. But gas molecules are independent, right? Gas particles are independent. They're all independent of each other. That's how it's described. They all move around independently of each other. That's why gas pressure is in all directions and all vectors possible at all times. So they claim that their atmosphere moves, which is gases, moves with the rotation of the Earth, is completely impossible because gases cannot have friction boundary layers to even get that started. Never mind the fact that they're not connected because they're independent, because they're unbonded. So thanks for having me in. Good show.
All right. Thank you very much, Brian. Anybody else?
Hoorah!
And
right.
that claim is debunked. And that claim is debunked by the gift that I'm posting in the chat.
And now a message from Meatball.
All right. Thanks, guys. I'll be back. Okay. Lot of gravity and atmosphere and gas pressure talk. Not my favorite subject, but hey, whatever. Anyway, we'll see you guys on Monday. Have a good weekend. Starting to get cold here, so I guess I better go outside and do the yard work I've been putting off all summer before it gets snowed on. But you guys have a good weekend. Take it easy. What's this Smurfer girl says? Oh, we should do a dumb shit Glober say show and who said that stupid shit trick. Oh, that's a great idea. Yeah, that is a good. I like that idea. Let's do that sometime for sure. Saturday show? I don't know. My wife has been out of town for the last couple of days. I think she's going to be here tomorrow afternoon. But maybe if I get the house cleaned up in time and have enough time in the morning. I got some shit I got to clean up before I get in trouble tomorrow night. But yeah, that'd be cool. All right, guys. Talk to you later. Thank you, PJ, Gadget. Appreciate it. Smurfer, everybody. Thanks for listening. Have a good one.